How can we raise up a giant? How do we give birth to a jungle warrior? How do we craft an airplane to take us around the world? Designers seeking to answer this strange mix of questions all came up with the same answer: twin booms. From the legendary Lockheed Lightning, to the Havilland Vampire, to the Fairchild pack plane, designers have turned to twin booms to meet some of the toughest challenges. Though their quirky looks raised some eyebrows, more often than not, the boomers of aviation proved to be works of genius. Even without its twin-tail booms, the Kalinin K-7 is arguably one of the oddest-looking aircraft ever constructed. Designed by Soviet World War I pilot Konstantin Kalinin, it was quite Frankenstein in appearance, with 7 engines bolted onto the wings and with 2 massive underwing pods. The pods housed the landing gear and were armed with machine gun turrets. It was a bold piece of engineering. The K-7's gigantic wings spread almost as far as B-52s, and it could carry 128 passengers, 150 fully armed paratroopers, or 21,000 pounds of bombs. Unfortunately for the Soviets, their pride in homemade products may have been their downfall. Kalinin had planned to use BMW engines, but a switch was made to Soviet AM-34 engines. They were badly underpowered, and a 7th pusher engine was added between the tail booms as a booster. The K-7's diminutive twin tail may have been chosen as a way of keeping total weight down. However, the twin booms turned out to be the K-7's Achilles heel. On its final flight, the tail boom began to shudder and fell to pieces. The Flying Giant went into a deadly dive. 14 passengers and 1 bystander on the ground were killed. It was a PR nightmare for the Soviets, who had bragged about the creation of a totally Soviet-made monster aircraft. The twin boom design also helped to get a flying shoe into the air. The BV-138 was a twin-boom amphibian aircraft built by German manufacturer Blohm & Voss. Seaplanes have to deal with a problem known as sticking, or the tendency of the hull to stick to the water during takeoff. Certainly, the BV-138's trimotors and rocket pods would have partially alleviated this issue. However, the designers at Blohm & Voss went one step further. They decided to give their seaplane a high twin-boom tail. The tail sat well above the waterline, meaning there was less hull surface area to stick to the water during takeoff. The shoe-like appearance of the clipped tailless fuselage earned this aircraft the nickname of Der Fliegende Holzschuh, or the Flying Clog. At first, the shoe was a good fit for Germany. At the start of World War II, it was the main maritime patrol and naval reconnaissance aircraft of the Luftwaffe. Later versions were equipped with a dural hoop for minesweeping. Perhaps the most notable achievement of the BV-138 was that it was also able to outduel another legendary seaplane in a dogfight, the consolidated Catalina. Though the shoe was an old favorite in the Luftwaffe, it soon became unfashionable. With the arrival of Allied carriers and more advanced fighters, the other shoe dropped, and the BV-138 was outmatched and obsolete. Twin booms could also provide an aircraft with a million-dollar view. The Abrams P-1 Explorer was designed by Talbot Adams specifically for aerial photography and mapping. The P-1's twin booms allowed Talbot to place the engine at the rear of the fuselage. This kept the camera free from oil and also improved forward visibility. The cockpit was pushed well ahead of the wings and was walled with framed plexiglass, giving the pilot and crew an unobstructed view of all ahead and below. Talbot continued to tinker with the design in the hopes that the plane might snare a buyer and become mass-produced. But when war arrived, all those plans were put on hold. In World War II, reconnaissance aircraft were just as vital to operations as bombers and fighters. They could gather tactical recon about the movements and defenses of enemy forces, assess bomb damage, and help pinpoint the positions of enemy targets in the battlefield. In 1937, Germany was looking for a 3-seat recon aircraft to help support ground operations. Arado offered up the AR-198, a conventional aircraft with windows in all directions to ensure good visibility. From Blom and Voss came Dr. Richard Vought's daring asymmetrical plane, the BV-141. Legendary Focke-Wulf designer Kurt Tank gambled on a twin-boom design when he conceived the FW-189. Like the Abrams Explorer, the aircraft's twin booms provided for a clearer view of operations below. A central crew gondola, walled with windows, and virtually sitting on top of the wings, offered an excellent view in all directions. Tank jeopardized the proposal by insisting on 2 engines rather than 1, but in the end, the FW-189 won the competition, and officially became Germany's eye in the sky. In all, 864 aircraft were produced in factories in Czechoslovakia and occupied France. The aircraft was particularly effective on the Russian front, where it gained the nickname the Rama, or frame, for the rectangular shape formed by the wing, tailplane, and booms. Russian fighters more often than not found themselves firing through the frame and hitting nothing but air. The FW-189, though not the quickest of aircraft, could outturn Russian fighters and blast them from behind with its machine guns. Visibility was also a paramount feature for night fighters searching for prey in dark hostile skies. It's not so surprising that the Americans chose a twin-boom design when they hatched the P-61 Black Widow. In 1940, Britain was looking for a night fighter of its own. The Luftwaffe's bombers were tormenting London, sneaking in under the cover of darkness. The RAF needed a high-altitude aircraft that could stand guard over London through the night to repel these invaders. Experiments were already underway, with a new key piece of night fighter technology, AI, or airborne radar. Radar would make a fighter a deadly nocturnal predator, able to pick out enemy aircraft in pitch darkness. A cash-strapped Britain shared the secrets of radar to U.S. manufacturers in the hopes of earning back royalties. Radar was the missing ingredient designer Jack Northrop needed to set loose his own deadly spider. His P-61 Black Widow was in many ways reminiscent of the FW-189. Both had twin booms, twin engines, and a central gondola with an excellent view in all directions. It was America's first aircraft to be installed with radar from the start. Like a spider sensing vibrations in its web, the Black Widow could detect enemy aircraft with the help of the radar unit housed in its rounded, protruding nose. Unlike the FW-189, the Black Widow was designed to be a killer, and its twin-boom design made it a crack shot. Originally, Black Widow carried 4 belly-mounted 20mm forward-firing cannons. Placing the guns in the center line made for more accurate shooting. Some variants also included 4 remote-controlled 50mm machine guns. The Widow could essentially strike approaching enemy aircraft coming from any direction in the upper hemisphere. A byproduct of its gun placement was more room in the wings for fuel storage. This was a critical feature, as the P-61 was designed to loiter for hours at a time. Many innovative features were packed into the Black Widow's fuselage. When asked about the twin-boom arrangement, Gerald H. Balzer, a former Northrop engineer, said, "The configuration of an airplane depends on what you want to cram into it." The P-61 arrived a little late in the war to have a significant impact, but there were other twin-boom fighters in the air causing mayhem for their opponents, including the fork-tailed Devil. One of the great strengths of the twin-boom design is the ability to place guns in the nose of a fighter without penalty. In World War I, the riddle of firing through a propeller without blowing it to pieces was solved with the invention of interrupter gears. In World War II, although it would have been theoretically possible to incorporate this same technology in some of the single-prop fighters of the day, there were the problems of additional weight and interrupter gears slowing the rate of fire. Fighters like the Spitfire and Mustang placed their weapons on their wings to avoid this issue altogether. Their guns were angled so the bullets would converge at a set distance in front of the aircraft. This, however, created another problem. A pilot had to wait till an enemy aircraft was the perfect distance away to ensure a good hit. This added a level of complexity to an already frenetic dogfight, which could lead to fatal results in the hands of less skilled pilots. Fighter pilots flying twin-boomed aircraft like the P-38 did not have to worry about conversions.
The reason the P-38 was so awesome in its firepower is because the guns were in the nose. When you fired 450s and 120 and it went straight out. And all the other fighters in World War II, the guns are out in the wings. So the fire goes, and right here is the only place that has maximum impact. The P-38's maximum impact all the way.
The Fokker G.1 was World War II's original twin-boom fighter. It first flew in 1937, but it did not see combat until May of 1940. Nicknamed Le Faucheur, or Reaper, it was designed to reap destruction. This twin-engine heavy fighter had a potent arsenal of weapons to clear enemy aircraft from the skies and gain air superiority. There were two 23mm cannons and up to 8 7.9mm machine guns in the nose. One machine gun was installed in the rear-facing turret to deal with any invaders sneaking up from behind. Dutch aircraft manufacturer Fokker received an order of 26 G1s from an enthusiastic Spanish Republican government, but the aircraft were never delivered. Though the Spanish paid for the Reapers, there was a Dutch embargo on the sale of military aircraft to Spain. Fokker, however, continued building the aircraft and issued a false press release that the fighters were for Finland. The G1s didn't see any combat until the Dutch were literally fighting for their lives. On the 10th of May 1940, Nazi Germany invaded the Netherlands. The Dutch threw everything they had at them, including 36 G1s built for the Dutch Air Force. The end result of the 5-day battle against powerhouse Germany was a foregone conclusion. The G1s that took part in the battle were able to smite back at the Germans, strafing infantry units and attacking transport aircraft, but it was not enough. Construction of the Spanish G1s continued at the Fokker plant, but for a new set of owners. The Spanish order went to the Luftwaffe, who used their brand new G1s as trainers. Perhaps the best-known example of a twin-boom fighter in World War II was Lockheed's P-38 Lightning. Though an odd sight at the time, it would prove a formidable fighter and earn the nickname of Fork-tailed Devil from the Germans. In 1937, the U.S. Army Air Corps was looking for a new aircraft and issued a tough set of specifications to the manufacturers of the day. They needed a twin-engine, high-altitude interceptor with a maximum speed of 360 miles per hour and the ability to climb to 20,000 feet in 6 minutes. The aircraft was also required to use Allison's V-1710 engines with turbo superchargers and preferably have tricycle landing gear. Legendary Lockheed designer Clarence Kelly Johnson was up for the challenge. He experimented with a number of twin-engine configurations, including placing pusher engines behind the fuselage. In the end, he settled on a twin-boom design, much like the G1 and the FW-189. The lengthy twin booms allowed him to fit Allison's bulky turbo supercharger into a slender aerodynamic housing. With supercharged engines and an aerodynamically efficient airframe, the P-38 became the first American aircraft to break 400 miles per hour. The twin-boom design was unusual for the time and did cause some trepidation for new pilots. There were stories circulating of pilots bailing out and getting decapitated by the props. However, as long as proper bailout procedures were followed, the Lightning was as safe as any other American aircraft in an emergency. Streaking out of the clouds, the Lightning could strike down its opponents with a deadly blow. All of the Lightning's firepower was concentrated in its nose, one 20mm cannon and 4 M2 Browning machine guns, and it had the advantage of pinpoint firing accuracy. The straight-shooting Lightning could consistently hit targets up to 1,000 yards away, sawing aircraft in half in a blaze of bullets. Top-scoring American aces Thomas Maguire and Richard Bong took full advantage of the P-38's precision, racking up 40 and 38 kills respectively against the armorless aircraft of Japan.
Dick Bong was fearless, absolutely fearless. He had one basic rule, and he's told me that on a number of occasions. He said, fly up their tail and blow them away. Don't start shooting a mile away. Run up on their tail, get right on their tail and let them have it. And that's the way he did it.
The P-38 Lightning and the Fokker G.1 were not the only examples of twin-boom fighters in World War II. The Swedes, too, had their own homegrown Saab 21. The Saab 21 was a twin-boom pusher aircraft, just like the Abrams P-1 Explorer. By incorporating a pusher engine, the designers ensured a clearer field of view ahead, unobstructed by rotating prop blades. However, there were legitimate concerns the pilot could get sucked into the propeller blades during a bailout. Although Saab toyed with the idea of jettisoning the propeller in an emergency, they determined an ejector seat was the best solution to the problem. Versatile twin-boom aircraft wore a number of hats during World War II. They were not just excellent spy planes and fighters, they also made top-notch transports. The Gotha Go 242 was a transport glider built to replace the DFS 230. The 230 was limited, as it could carry 9 troops only in tight quarters, and they had to enter and exit via a small side door. The German Air Ministry, the RLM, was looking for a serious upgrade, something that could carry twice as many troops and equipment. Albert Kalkert of Gotha was able to give the RLM everything they wanted when he designed the Go 242. The box-like fuselage of this high-wing monoplane ended in clamshell doors, through which 20 troops or a small vehicle could march or roll in. The high twin-tail booms made this door arrangement possible. The gliders were towed into the air by HE-111s or Ju-52s. By adding rocket pods, the Go 242 could be loaded with even more men or machines. It was a widely used aircraft. Over 1,500 were built. Some were even fitted with radial engines when they were converted into Go 244s. America too experimented with twin-boom transports and created their own flying boxcar. With its twin tails, high wing, and low-hung fuselage, Fairchild's C-82 packet plane was the same basic shape as the German Go 242 and 244. The C-82 was designed to replace conventional transports like the Douglas Dakota. Though a workhorse transport, loading wheeled vehicles like Jeeps into the DC-3 was not the most elegant operation, while the low-hung fuselage of the C-82 allowed vehicles to just roll in. Officially named the packet plane, it was aptly nicknamed the Flying Boxcar, as it had virtually the same capacity as a standard railroad car. The Boxcar lost some steam early in its career. The aircraft just didn't have the power to lift heavy cargo. It also arrived late in the war, and only a few were in service by war's end. 223 were built, and some took part in the Berlin airlift. Though the C-82 was something of a disappointment for Fairchild, their packet plane would have a second life. The C-82 was modified into the much more capable C-119. The C-82's high cockpit was moved to the nose of the plane to create more room for cargo. As well, the airframe was strengthened, and more powerful engines were installed to increase the carrying capacity. Maximum takeoff weight ballooned from 54,000 to 74,000 pounds, and troop carrying capacity increased from 42 to 62. The C-82 had been nicknamed the Boxcar, but now with the beefier C-119, it was official. During the Korean conflict, the C-119 made a name for itself as a bridge builder. In late 1959, the Chinese PLA destroyed a key bridge between Koto-ri and Hungnam. 8 U.S. Air Force C-119s carried an entire bridge, piece by piece, to restore the escape route between the two cities. Each of the 8 bridge sections were 2,900 pounds and 16 feet long. In the 1950s, other aircraft manufacturers looked to capitalize on the same basic twin-boom design of the Boxcar. In France, Nord Aviation produced the Nord Atlas, and in England, Armstrong Whitworth developed the AW660 Argosy. This was a 4-engine turboprop with the cargo space of a typical flatbed truck. Its pod and twin-boom structure earned it the nickname the Whistling Wheelbarrow. In both cases, each aircraft had large doors at the rear to accommodate bulky pieces of cargo. While Nord Atlas and Armstrong Whitworth were interested in these conventional transports, back at Fairchild there was an attempt to create an even better mousetrap. Their XC-120 packplane streamlined the whole transport process. Traditionally, cargo was unloaded from truck and reloaded onto aircraft box by box or crate by crate. But what if there was a universal container that could detach from a truck and reattach onto a flying vehicle, substantially shortening loading time? This was the premise behind the XC-120 packplane. Fairchild took the fuselage of a C-119B and sliced it below the flight deck. They wanted to fit a rolling detachable pod underneath, so they raised the fuselage a few feet higher by angling the wings upward. It wasn't possible to have a traditional nose wheel, so 2 mini landing gear sets were added forward of the main gear. The landing gear was adjustable, so pod loading could be expedited. In addition to carrying cargo, the packplane might carry a specialized mobile hospital pod, mobile buildings, or pods to transport paratroopers. It seemed an ingenious idea, but the U.S. military failed to show any real interest, and instead purchased more traditional transports. The whole idea behind the packplane was crated up and discarded. The 1950s saw the gradual decline and retirement of many of the dependable prop-powered warriors of World War II. The new generation of fighters was jet-powered. Though there were several successful jet fighters in World War II, it took time for this technology to mature. When British manufacturer de Havilland conjured up the Vampire, they chose a twin-boom design to mitigate some of the weaknesses of early jet engines. The Vampire was built around a single Halford H-1 engine, nicknamed the Goblin. The engine had only 2,300 pounds of thrust, and de Havilland engineers did all that they could to make full use of the power available. The Vampire was an extremely lightweight plane, made of molded plywood and metal, and it had 2 slender tail booms. Designers chose a twin-boom design to keep the jet pipe as short as possible. If they had used a conventional single tail, the exhaust would have had to travel a few feet farther, leading to a loss of power. The Vampire didn't have the greatest range to begin with, but when fitted with the next generations of Goblin engines, it became a record-setter. The aircraft was in fact the first jet to cross the Atlantic when, on the 14th of July 1948, 6 RAF Vampires of No. 54 Squadron RAF traveled from Stornoway, Scotland to Goose Bay, Canada, with stops in Iceland and Greenland. Buyers weren't scared away from buying the Vampire and Ghost combination. Over 3,000 were sold in various configurations to over 30 air forces worldwide. The designers at Saab decided to add some Goblin power of their own to one of their reliable prop designs. Rather than build a new jet fighter from scratch, they chose to retrofit their pusher Saab 21 with a Goblin 2 engine. Back at de Havilland, designers continued to improve on the success of the Vampire design. In 1949, de Havilland unveiled the Venom. Although there were some modifications, this was essentially a Vampire with a new engine, almost twice as powerful, the de Havilland Ghost. In 1951, de Havilland made a much more radical change to the Vampire's original design. They created a twin-boom, twin-engine aircraft with swept wings for the Fleet Air Arm. It was known as the Sea Vixen. The Vixen had a major upgrade in engine power. It used two Rolls-Royce Avon engines with 7,500 pounds of thrust each, enough power for it to reach sound-breaking speeds in a shallow dive. The Sea Vixen had a unique two-seat arrangement.
The pilot's point of view may be that it was all right as an airplane, but what did the observer think? He was in a coal hole on the right of the pilot, and he was completely enclosed in there. And he hadn't much idea of what was going on outside. I would think it was a most unpleasant experience to be an observer on a Sea Vixen.
The Vampire and Venom had both been adapted for carrier use, but the Vixen was a purpose-built carrier-based fleet defense fighter. The aircraft could carry a complement of missiles, rockets, or bombs, including nuclear weapons. In some models, additional fuel tanks could be stored in enlarged tail booms, which jutted out of the top of the wings. The Sea Vixen proved a capable fleet defense fighter, which served the Royal Navy until the 1970s. However, it did have an unusually high accident rate.
Night landing, deck landing is never easy. But a big airplane like this, it had the sad fault that the ailerons became very ineffective at the low speeds at which deck landing are carried out. And this caused problems with lining up the aircraft with the center line of the carrier at night.
Twin-boom aircraft were built with a multitude of engine arrangements throughout aviation history. There were twin jets like the Sea Vixen, single jets, twin prop planes, and pusher planes, just to name a few. But in the 1960s, an aircraft appeared which tried something different. The Cessna Skymaster had a push-pull configuration. There was a prop in the aircraft's nose and another in the rear of the fuselage. Cessna chose this design as safety was the main selling point of the aircraft. It was an interim replacement for the O-1 Bird Dog. With a single-engine aircraft like the Bird Dog, there is always the danger that the one engine might fail in mid-flight. The Skymaster's second engine was a fail-safe. As well, with twin-engine aircraft in a side-by-side arrangement, there is the issue of yaw should one engine fail in flight or during takeoff. The center-line thrust of the push-pull configuration ensured that the Skymaster would not veer out of control in these situations. It was a successful aircraft with almost 3,000 produced for military and civilian use. When the U.S. became entangled in the Vietnam War in the 1960s, the O-2, the militarized version of the Skymaster, served as a forward air controller and light observation aircraft, marking targets for heavier fighters and bombers. The O-2's second engine was invaluable should one give out over hostile territory. However, the O-2 wasn't particularly fast with both engines turning. With one damaged, it was a sitting duck. The Skymaster would be succeeded by another twin-boom aircraft especially built for the rough-and-tumble action of Vietnam, the OV-10 Bronco. When W.H. Beckett and Colonel K.P. Rice of the U.S. Marine Corps conceived the Bronco, they wanted to create a close air support aircraft that could operate from jungle roads. Twin booms were vital to the concept. They were impressed by the shooting accuracy of twin-boom fighters like the P-38, and wanted to include a 106mm recoilless rifle along the center line. The tailplane had to be high up on the tail booms just to avoid the backblast. The enthusiastic duo built the fiberglass prototype in Rice's garage, but they had a hard time convincing the U.S. Armed Forces of the benefits of the Bronco. But with things heating up in Vietnam, a specification for a light armed reconnaissance aircraft, LARA, was given the green light by the Navy, Marines, and Air Force. They were looking for a light attack and observation plane to replace the O-1 and O-2, and the Bronco fit the bill. The production version of the Bronco was not quite what Beckett and Rice had envisioned. The Bronco had become a heavyweight warhorse. Over 2,000 pounds of extra electronics, an ejection seat, and a more rugged landing gear meant operation from dirt roads was out of the question. It also lost the recoilless rifle that Beckett and Rice had longed for. The new design wasn't left defenseless, however. It could carry up to 3 tons of external munitions and 4 M60C machine guns. With these alterations, the Bronco still became one of the top-notch counterinsurgency aircraft and remained so for the next 30 years. In Vietnam, the Bronco had a twin-boom stablemate which proved you can teach an old dog new tricks. The C-119 Boxcar, which had made a name for itself in Korea building bridges, was tasked with a deadly new mission. In Vietnam, the flying boxcars were transformed into flying gunships. They had a major upgrade in firepower and other equipment to complete the transformation. The AC-119G Shadow was readied for battle with armor plate, 4 Gatling miniguns, infrared sensors, and flare launchers, while the AC-119K Stinger was upgraded with 2 GE M61 Vulcan 20mm cannons and 2 underwing turbojets adding 6,000 pounds of thrust. In 1986, a twin-boom design attempted a first in aviation, a non-stop trip around the world without refueling. Burt Rutan's Model 76 was extremely lightweight. The airframe weighed only 939 pounds. As there would be no pit stops along the way, every pound counted. The twin booms were essentially huge fuel reservoirs. There were additional tanks in the wings, fuselage, and the canards, and it took 7,000 pounds of fuel to fill them all up. The aircraft had 2 engines, one in the front and one in the rear. The front engine was fired up during takeoff and the early stages of the flight, when the Voyager was heavy with fuel, but it was switched off for the remainder of the voyage. On December 14, 1986, Dick Rutan and Gina Yeager set off from Edwards Air Force Base for a trip around the world. The Voyager had a bumpy start that morning. The wings, sagging with fuel, scraped against the runway during takeoff, but the damage was minimal. Though they had to circumnavigate some hostile weather and had a faulty fuel pump to contend with, the trip went largely as planned. Perhaps the cramped conditions and the stress of the situation were the greatest obstacles of all. After 9 days, 3 minutes, and 44 seconds, on December 23, 1986, the exhausted duo returned to where they had started. The Voyager and her crew were victorious. Their triumph was shared with thousands of cheering spectators and the press who beamed the Voyager's round-the-world trip around the globe. When twin-boom aircraft first appeared, they were an odd bird, but their eccentric designs proved to be a stroke of genius. Designers faced with tough specifications often turned to boomers for the answer. Whether mapping the globe, circling the globe, or leading the charge into battle, time after time, twin-boom aircraft demonstrated their worth. Where twin booms will next take us, we can only guess. The sky is no longer the limit.
Getting troops and equipment through the air and quickly on the ground and into combat. This was a challenge tackled in World War II with the use of gliders like the Waco. However, gliders were built to be expendable and could not be returned. They also had to rely on another powered aircraft for towing. A major problem for glider pilots was that they only had one chance at landing. This meant that they could not avoid obstacles unseen from the air, or even deliberate traps set by the enemy. Many glider troops never even got to battle. They simply perished in their vulnerable wooden hulls. Sometimes the means of arrival was even more deadly than the enemy, and this was equally the same for both sides. Early in the war, the Germans produced the Gotha 242, a fairly successful glider that used a twin-boom tail arrangement. The 242 could carry a useful payload, which would be quickly unloaded through a large rear door. Some of the Gothas were fitted with small French piston engines, which negated the need for a tow plane. However, the most important feature of the powered glider was that its pilot could choose exactly the best place to land without running out of height. It also meant that after unloading, the aircraft could quickly take off and return to its base for another mission. This is the U.S. Air Force's Fairchild C-123 provider. Much like the Gotha 242, it was originally built as an unpowered assault glider. Then later, engines were added. However, the glider version was nothing like the wooden Wacos and Gothas used in World War II. This aircraft was big and made entirely out of metal, and was also heavily reinforced for crash landings. If American soldiers had to glide to war again, then their safety was going to be a major consideration. Only 2 of the giant glider versions were built prior to the whole unpowered flight program being abandoned. However, the motorized version did go into production, and over 300 were successfully deployed. The provider was very robust and able to cope with short and primitive landing areas. However, it wasn't considered quite as expendable as a Waco, which could fly right into a battle scenario. Shortly after war's end, American designers and military experts discussed the lessons learned from the conflict, speculating that it might be possible to land equipment without an aircraft actually landing, or at least not stopping. This idea, and other novel concepts of aerial support for ground soldiers, soon earned strong encouragement from a very qualified source, in the form of General Jim Gavin, often called the Jumping General due to his insistence on parachuting with his men in the 82nd Airborne. Gavin was a larger-than-life general who understood the needs of airborne support, and later from a post in the Pentagon championed the cause of the pod. However, the question still remained, would it even be possible for a powered aircraft to simply discharge its cargo on flyby? The Materiel Division at Wright-Patterson were given the task of finding some kind of device which could egress from a moving aircraft at a very low level. The concept of a pod began to evolve, totally self-contained and of sturdy construction. Test pods were built and vigorously tested. The main test involved pods being dropped from under the wings of a B-26 bomber, serving as a mother plane for the experiment. At first, the pods were released while the B-26 was still on the ground, taxiing at about 100 miles an hour. The results were mixed, but showed potential. However, when the pods were dropped from a mother plane in low-level flight, and out of range of propeller wash, the separation worked quite well. If these experiments could be translated into full-scale practice, then the opportunities could be limitless. The next problem was to find a suitable carrier aircraft, and here the Air Force looked to a Fairchild provider stablemate, the C-119 Boxcar. The Boxcar had evolved from the Packet. Both aircraft employed the same twin boomtail configuration once used on the earlier German Gotha gliders. These were purpose-built heavy transport aircraft with powerful engines. A single C-119 was totally reconfigured at Fairchild's Hagersfield plant to convey a parasite pod from one destination to another. Evolving into the XC-120 pack plane, the lower half of the Boxcar was completely removed and the landing gear converted from the traditional tricycle arrangement into a quad configuration, leaving a suitable clear space to accommodate the pod. To lift the enormous loads into the air, the pack plane was equipped with 2 Wasp 4360 engines, which were actually more powerful than those used on the B-29. The engines provided enough power to carry Fairchild's Giant at 250 miles an hour, fully loaded. The pack plane itself had a crew of 5, 2 pilots, an engineer, and 2 especially trained loadmasters. The crew would operate a totally self-contained power hoist to upload or download the pods, and each pod had its own set of wheels to facilitate towing. Connecting the plane to the pod was achieved via 4 special clasps located on the top of each pod. Although just as important, surrounding the outer edge of the pod was an inflatable seal, driven by compressed air. This was to ensure the airflow of the speeding plane did not separate its cargo. Each pod had a drive-through layout, allowing for loading at both ends, or cargo to be driven on at one side and off at the other. Either way, it was a capacious unit able to support 20,000 pounds of freight, or over 60 well-equipped troops. Alternately, the pod could be configured as an ambulance or a massive fuel tank. There were also plans for totally self-contained suites as workshops, headquarters, or even hospitals, all able to be delivered as complete standalone units. The pack plane, with its rapid collection and drop-off capability, provided awesome displays to the military and public alike, and possibly seemed to have had serious appeal as an acquisition to the military. And to some extent it may have, although not sufficient to gain a production contract. Only one of this remarkable aircraft was ever built, and then a few years later, it was scrapped. However, if General Gavin's pod concept didn't live up entirely to his expectations, then certainly his prediction for the need of a frontline support transport with very rapid offloading did. The conflict in Vietnam provided many such uses for Lockheed's remarkable C-130, and nowhere more so than in the battle for Khe Sanh. In 1968, the North Vietnamese laid siege to an American Marine base. The objective was on a plateau in the Khe Sanh Valley in South Vietnam. Over time, the NVA surrounded the base, cutting off all land communications. Coinciding with the North's Tet Offensive on Saigon, holding the Khe Sanh base became a critical political as well as military U.S. objective. The siege lasted for almost 3 months, and for much of that time, the only way in or out was by airlift, and this was mostly achieved under heavy enemy fire. The assault transport's time had really come. Only aircraft like the C-130 and the C-123 could survive the relentless touch-and-go tactics demanded by the situation in Khe Sanh, which required rear-door delivery, sometimes speeding on the runway and sometimes over it. The determined use of American assault transport under persistent enemy fire held the line. High-speed ejection of cargo, fast turnaround, and low-level parachute drops all played their role. The U.S. had exactly the right types of aircraft at the right time. Versatile, rugged, and purpose-built for need. Things may have been very different on that plateau in Southeast Asia, without the need having been defined by the experience of men like General Gavin. In truth, the pack plane would probably never have worked well in a frontline combat situation. The demands of sophisticated and careful handling on a quiet tarmac in Hagersfield, Maryland, is very different from the mayhem of a furious battle for a Marine base in the Khe Sanh Valley. But was the pod concept really so far off? Amongst General James Gavin's other predictions was the increased need to use helicopters in modern warfare. This is the Sikorsky S-64. The civilian version is known as the Sky Crane. The S-64 was extremely successful doing recovery work and reconstruction in Vietnam. However, they also had another application of delivering purpose-built modules designed for specific functions, such as field headquarters, workshops, and hospitals. Some even called them pods.
Of all the U.S. fighters during World War II, only one remained in production throughout the entire conflict: Lockheed's P-38, the Lightning. Thanks to its firepower, speed, and the reliability of its twin engines, this versatile and advanced design became one of America's most durable and valuable assets.
It was the best damn airplane ever built, as far as I am concerned. It was like flying a Cadillac automobile.
It was just an aviator's dream to fly in a P-38. It made the war in the Pacific.
We had very few planes that could keep up with the speed of the German planes or even the Japanese planes, so they needed something that would be able to be competitive.
In 1933, the newly restructured Lockheed Aircraft Company gambled its future on developing an advanced twin-engine aircraft it hoped would remain at the forefront of aviation for the next decade. To test the design, A scale model was built at the then staggering cost of $5,000 and sent to the University of Michigan for wind tunnel testing. During this process, Lockheed's executives met a young engineer named Kelly Johnson. His innovative aircraft design ideas so impressed the company that he was quickly hired. This marked the start of a brilliant partnership, helping Lockheed become one of the world's leading aviation companies. In 1933, the new project involved significant risks during uncertain times. Perhaps Lockheed's greatest advantage against failure lay in the human resource of its talented staff. Although the company was becoming increasingly automated, this was still an era when technicians saw themselves as craftsmen, and Lockheed's production teams embodied an old-school dedication with immense pride in their work. They also understood that the company's future depended on the success of the new multi-purpose twin-engine aircraft. For the model to succeed, it wasn't just a commercial airliner that was needed, but various types of military aircraft as well. From this basic model, several variants, including the well-known Hudson bomber, went into mass production. In some ways, global politics worked in Lockheed's favor. The rise of the Axis powers, especially Germany's rearmament, highlighted an emerging threat to world peace and underscored the need for expanding American air power. Soon, the U.S. Defense Department identified the need for a high-speed anti-bomber aircraft, but they set the specifications so high that few in the industry believed they could be met. Lockheed assigned the project to Kelly Johnson, who believed the required maximum speed of 360 miles per hour was attainable, but only by using an aircraft with the power of 2 engines. In fact, Johnson's design surpassed expectations, capable of reaching over 400 miles per hour. Normally, a twin-engine configuration would result in poor maneuverability, but Johnson countered this with a brilliant twin-boom design. This innovation secured a Defense Department contract in June 1937 to produce a single aircraft, the Model 22, at a fixed price of $163,000. Once again, Lockheed was taking a major risk. The prototype would end up costing 5 times that amount. However, this extra investment proved to be one of the company's best decisions. The Model 22 was officially designated as the P-38 fighter. With Europe on the brink of war, production of the aircraft remained highly secret. By January 1939, after minor modifications to the braking system, the new aircraft was ready for its first flight. On January 27, the first XP-38, precursor to nearly 10,000 fighters, took flight for the first time. Securing government funding for armaments was still politically sensitive, and the Army Air Force recognized the need for public support for the P-38. To garner this, they unveiled the project by announcing an attempt to break the Trans-America airspeed record. On February 11, 1939, the only P-38 in existence, with just 6 hours of flight time, embarked on its record-setting flight. Lieutenant Ben Kelsey was at the controls, with the American public and taxpayers watching closely. To cover the journey, Kelsey refueled at Amarillo and Brightfield before reaching Mitchell Field. These stops added about an hour to the total flight time, but the aircraft still completed the 2,490-mile trip in just 7 hours and 43 minutes, only slightly longer than Howard Hughes' previous record, which had been set in a specially designed plane carrying enough fuel for the entire trip. Unfortunately, during Kelsey's final approach to Mitchell Field, the aircraft struck a line of trees, crashed, and was destroyed. However, the plane's impressive speed convinced the Defense Department to immediately award Lockheed a contract for 13 YP-38s. The aircraft were to be equipped with a 37mm cannon and 4 machine guns, 2 30mm and 2 50mm, making it one of the most heavily armed fighters of its time. Within months, even more firepower was added, while interior design changes nearly doubled its ammunition capacity. Lockheed was now firmly in the fighter business, and the Burbank plant was restructured for mass production, resulting in approximately 30,000 minor design changes. Additional modifications were also required to reduce the buffeting and address a phenomenon known as compressibility, which caused the aircraft to vibrate during certain maneuvers, particularly when diving. The true solution to the compressibility issue wouldn't be discovered for several years, but these minor setbacks didn't slow the progress of what was considered the world's best interceptor. In September 1939, as Germany invaded Poland and plunged Europe into World War II, the Army Air Force ordered an additional 66 P-38s on the same day the first P-38 made its maiden flight. From the outset, protecting the pilot with armor was a top priority. Throughout its service, the P-38 underwent constant testing to enhance its resilience against enemy fire, with pilot safety being paramount. The plexiglass canopy and armor plating around the pilot were rigorously tested with gunfire. In June 1940, the British ordered 600 of these impressive aircraft, naming them the Lightning. However, due to the secrecy surrounding the vital superchargers, they were only provided with a less powerful engine and aircraft equipped with propellers that rotated in the same direction. This hybrid version proved underpowered and difficult to handle, and the British accepted only 3 before dubbing them castrated Lightnings and cancelling the order.
The British didn't like the airplane. And they had been in conflict for quite a while, and they knew airplanes, and they didn't want that thing. And it was a real dog. It didn't have some turbo. It didn't fly high. All the props turned in the same direction.
However, the name Lightning remained with the aircraft throughout its career. The American model retained the key features, including counter-rotating propellers that provided stability to the twin engines. Behind the engine was the critical General Electric supercharger, which transformed average engines into powerful units. By late 1940, Lightnings were rolling off the production line. These aircraft were exceptionally powerful, boasting a high rate of climb, long range, and the safety of twin engines, making them popular with pilots. Unfortunately, the compressibility issue continued to limit high-speed performance.
The P-38 was having a problem, credibility problem. Pilots are aspiring pilots and heard some things that weren't very complimentary about the P-38. Now, as young cadets, 20, 21 years old, we really didn't know what compressibility was at the time, but that was one of the rumors, that the P-38 was a dangerous airplane if it hit compressibility.
In the early 1940s, pilot training began in 2-seater, single-engine biplanes, which were much lower in power. The trainee pilot always had an instructor present, but when a young pilot first sat in the cockpit of a twin-engine Lightning, he was entirely on his own. This created significant challenges given the plane's immense power. To address this, an awkward attempt was made to add a second seat in the port boom cockpit. More effective, however, was the piggyback concept. The radio was removed from behind the pilot's seat, allowing the instructor or trainee to crouch there, ensuring that the first-time pilot didn't have to manage the Lightning's intimidating power alone. The Lightning also introduced several unique features, such as a spoked steering wheel in place of the traditional joystick and dual-engine related controls for turning. The tricycle undercarriage was another innovation that pilots favored, as it made takeoffs and landings much easier than the standard tailwheel design. Landings were particularly safer, as the Lightning could land at higher speeds without risking a stall. During training, pilots were taught to always wind up the side windows, as failing to do so would disrupt the airflow during takeoff, causing severe buffeting from the resulting turbulence. New crews often worried about the dangers of bailing out of the twin-boom P-38, fearing the rear elevator slab might act like a blade and strike them as they exited the aircraft. However, as this training film emphasizes, those concerns were unfounded.
Bailouts can be made either 1, by turning the plane on its back and dropping out, or 2, by getting out the left window and sliding down the wing. Now don't stand on the wing to jump.
The quality of the training was soon put to the test. After the attack on Pearl Harbor, America entered the war, and peacetime pilots transitioned into combat roles. Due to its long range, the P-38 could be flown in stages across the Atlantic to Britain. A squadron was stationed in Iceland to protect the staging airfield and patrol sea routes, attempting to intercept German long-range reconnaissance planes that were attacking ships and guiding U-boats. Without radar, these efforts were typically unsuccessful. However, on August 15, 1942, a patrolling P-38 spotted a Focke-Wulf Condor, and Lieutenant Shanahan shot down the German plane within seconds, marking the Army Air Force's first victory against the Luftwaffe. Focke-Wulf also produced the stub-nosed FW-190, which is often regarded as the best dogfighter of the entire Second World War in Europe. Alongside the Messerschmitt 109s, these aircraft had a devastating impact on early 8th Air Force daylight bombing campaigns against Germany. Without fighter protection, the early B-17s were shot down in alarming numbers, and at one point, the entire strategic bombing campaign was at risk. It became clear that to continue long-range daylight bombing, long-range escorts would be necessary. The Lightning emerged as the obvious choice, and American fighter crews were eager to showcase the P-38's potential. However, those stationed in Britain were initially sent to support the more urgent North African campaign, delaying the development of the bomber escort program. Typically flying along P-47 Thunderbolts, Lightning pilots would receive briefings on fighter protection and coordinate with the 8th Air Force heavy bombers. Finally, Lightnings were set to engage the Luftwaffe on equal terms. The results of these early encounters were mixed. While the P-38 had impressive diving capabilities at high speeds, it was not as agile as the FW-190s at high-altitude engagements. Instead, the Lightning proved more effective at lower altitudes, where it could dive on German fighters as they climbed to attack B-17 bomber formations. A high-speed dive attack was effective for only one approach, but with the Lightning's heavy firepower, an accurate pilot could make it the best way to engage German fighters. In the skies over Europe, the Lightning earned the German nickname Fork-Tailed Devil. The 8th Air Force's fighter escort operations were largely successful, resulting in significantly fewer B-17s being lost to enemy fighters. Additionally, it became standard practice for American fighters returning from escort missions to strafe enemy ground targets. In this role, the P-38 became legendary. Its long range and formidable armament made it a deadly ground attack aircraft. German airfields were prime targets, and American fighters employed the same tactics used by Germany against England during the Battle of Britain, attacking German aircraft where they were most vulnerable, on the ground. The combat experiences led to enhancements in later models of the P-38. This is a light G model, which featured an enlarged chin intake under each engine. Improvements were also made to the aircraft's armament, with the cannon and machine gun combinations often being varied to increase firepower. Additionally, the wing tank hardpoints were now being utilized to carry 500-pound bombs, proving that this aircraft, originally designed as an anti-bomber interceptor, could also effectively serve in ground attack roles. Flying low off the Californian coast, this late model P-38 tested a new weapons combination. The issue of compressibility, identified as the buildup of shock waves over the airframe at high speeds, was finally addressed. Special flaps fitted under the main spar were tested and eventually installed on all late J models and widely used L model. These flaps provided a nose-up attitude during dives, keeping the aircraft stable and manageable in various flight positions. With these improvements, Lockheed's powerful Lightning became a nearly perfect fighting plane. These L models, based in Italy, showcase the aircraft's capabilities. Like all Lightnings, their performance relied heavily on the General Electric supercharger. When an aircraft was scrapped for any reason, maintenance crews would salvage reusable parts, placing particular emphasis on the crucial supercharger. Even in a state of decay, this P-38 held value for the Allied war effort. Maintaining twin-engine aircraft was, understandably, more time-consuming than caring for their single-engine counterparts. The ground crew's dedication was as crucial to the success of operations as that of any pilot. This squadron was being prepared for a ground attack mission. The decision to carry either drop tanks or bombs depended on the specific requirements of the mission. In this case, long-range capability was necessary. For ground attack missions, 2 500-pound bombs would be more suitable. In reality, P-38s were capable of carrying much heavier bomb loads, and the F model could even deliver 2 torpedoes. However, it was the versatile 500-pound bomb that saw the most frequent use. Immediately following their briefing, crews would depart to fly their missions, embodying a mix of determination and camaraderie. Each man hoped that the mission would be no more than a routine hulling job, but they were all aware that it could be anything but that. Throughout World War II, pilots recorded their victories on the sides of their aircraft, serving as both a morale booster and an accolade. This practice, which originated during World War I, was common among the air forces of all combatant nations. Some pilots placed all their trust in their aircraft, while others relied on sentimental objects for luck. All personal effects that could fall into enemy hands had to be surrendered before takeoff, and until they returned, the mission was paramount. This remarkable footage, captured from a camera suspended beneath the wing of a P-38, provides a glimpse of what Army Air Force pilots experienced during a routine interdiction mission. Back at Burbank, the final stages of P-38 production were often carried out outdoors, taking advantage of the clear Californian weather. However, the main plant was anything but exposed. The Lockheed factory, like other production facilities on the West Coast, was considered a prime target for Japanese suicide attacks. Given the critical role of the Lightning in the war effort, the Defense Department went to extraordinary lengths to camouflage this essential facility. The main Burbank factory underwent an impressive transformation, with the entire roof designed to resemble a paddock with rolling hills and even fake farmhouses to mislead Japanese aerial attackers. The reconnaissance version of the P-38 had no armament whatsoever, as it was equipped with large cameras mounted in the nose and relied on its speed for protection as well as on its paintwork. Early in the war, the Army was approached by Mr. Samuel Cabot, who offered a paint that would make aircraft invisible at altitude. Initially, the idea was dismissed, but later, in collaboration with the Sherwin-Williams Paint Company, a product was developed that made the P-38 almost invisible when viewed from the ground. The haze blue camouflage proved to be a remarkable success, yet its usage has seldom been highlighted. However, pilots who flew reconnaissance Lightnings were well aware of its effectiveness. In this footage, one of the haze blue reconnaissance planes flies alongside the standard olive drab of the fighter. The P-38's role in photo reconnaissance, particularly in the Pacific, was arguably its most vital function. As soon as a plane landed, the camera pack would be unloaded and the film processed immediately, allowing tacticians to assess the situation without delay. Many of the war's most crucial decisions relied entirely on these photographs. Given the value of the intelligence gathered, the reconnaissance Lightnings likely saved more lives than any other piece of hardware in the conflict. An unusually colored P-38 named Yippee was the 5,000th aircraft off the production line. To celebrate this milestone, it was painted in a bright vermilion, with its personalized name emblazoned on the nose and across the underside of the wings. Despite the striking exterior, if you look closely, you can see that the interior still retained the conventional drab olive color. When Lockheed first submitted its proposal to the Defense Department, it never anticipated producing 5,000 Lightnings. However, by the end of the war, the total figure would nearly double that number. Another chapter in the story of this versatile aircraft was the Pathfinder program. In early tests, the armament was removed to make space for a second crew member, equipped with instruments to act as a bomb aimer, guiding other aircraft to their targets. This was only a developmental example where the concept was initially explored, using sandbags to mimic the weight of the second crew member. The program continued, and P-38s with specially enlarged forward fuselages, known as droop snoots, eventually entered production, providing excellent service as pathfinders. On the business end of the Lightning, the armament typically consisted of a combination of machine guns and cannons. The aircraft's immense firepower, combined with its ability to avoid shooting through propellers, gave it a significant hitting advantage over Axis competitors. At a Pacific base, a crashed C-46 serves as an improvised control room for the Twin Dragon Squadron. Here, a pilot inspects repairs to damage sustained from enemy gunfire before heading out once more on a ground attack mission. Not all targets in the Pacific were static. Japanese fighters could be both prey and predator. While the Zero was incredibly nimble, other Japanese aircraft were less capable. Captain H.H. Seeley, nicknamed Light Horse Harry, was a P-38 ace with 10 confirmed kills and 1 probable. However, the all-time Lightning ace with an impressive 40 kills was Richard Bong. Bong flew all of his combat missions in P-38s, and even the legendary agility of the Zero was no match for his almost uncanny ability to down enemy aircraft. Bong was awarded the Congressional Medal of Honor after his 25th combat success and returned to the USA in early January 1945. He went on extended leave and married his longtime fiancée before reporting to Lockheed in early June for duty as a test pilot, where he would fly the new jet-powered P-80. Tragically, with very little experience on the aircraft, he was killed in a P-80 that flamed out on takeoff. The date was August 7, 1945, the same day the atomic bomb was dropped on Hiroshima. The last of the Lightnings, the P-38M, was in many ways the most intriguing, a jet-black, radar-equipped night fighter. 75 were produced as modifications of P-38Ls. These aircraft prowled the night skies over the Pacific theater, seeking out Japanese targets and protecting U.S. airstrips. Though they came late in the war and did not see much active service, when they did, they demonstrated the concept's viability, leading many enemy pilots to regret their effectiveness. To accommodate the radar operator, the piggyback concept was pushed to the limit, with a blister canopy added to provide a cramped space above and behind the pilot, where the operator would huddle, peering into a tiny screen. The guns featured special blast shields on the muzzles to prevent the flash from interfering with the pilot's night vision and effectively blinding him, while the radar was mounted under the nose in an external module. On the day Japan surrendered, over 2,000 more P-38s were on order, but only those that were under construction at the war's end were completed, as the remaining orders were cancelled. In total, 9,923 P-38s were produced, but as production ceased, Lockheed's Burbank plant was already churning out the P-80, America's first production jet fighter, the very plane Major Bong had been testing, but he was tragically killed. Within a few short years, the P-38 was being phased out of use. However, for those who built, serviced, and flew the Lightning, it will always remain one of history's truly great airplanes.
The Northrop P-61 Black Widow is a twin-engine United States Army Air Force fighter aircraft of World War II. It was the first operational U.S. warplane designed as a night fighter, and the first aircraft designed specifically as a night fighter. Created by Northrop Aviation in collaboration with the British Royal Air Force, the P-61 was also the first aircraft designed to use radar. With its mysterious appearance and name, the Black Widow ruled the night in the waning months of World War II. When World War II began, the U.S. Army Corps and the British Royal Air Force flew mostly outdated aircraft compared to the war-ready counterparts on the Axis side. In August 1940, 16 months before the United States entered the war, the U.S. air officer in London, Lieutenant General Della C. Emmons, was briefed on British research and radar, which had been underway since 1935 and had played an important role in the nation's defense against the Luftwaffe during the Battle of Britain. General Emanos was informed of the new Airborne Intercept Radar, AI for short, a self-contained unit that could be installed in aircraft and operated independently of ground stations. In September 1940, the Tazard mission traded British research, including the cavity magnetron, that would make self-contained interception radar installations practicable for American production. Simultaneously, the British Purchasing Commission, evaluating U.S. aircraft, declared their urgent need for a high-altitude, high-speed aircraft to intercept the Luftwaffe bombers attacking London at night. Night fighters would soon become their own category of aircraft. A night fighter was a fighter concept. Still, it wasn't until after the catastrophic bombing raids over Europe, particularly the London Blitz in 1940, that the military air force has really found a need for a plane catering specifically to these types of missions. The Northrop Aircraft Corporation, located in California, had only been in active operation since 1939, mainly as a subcontractor for larger aircraft manufacturers. It was definitely an unlikely candidate to develop the world's first night fighter. More prominent corporations such as Lockheed, Grumman, and Douglas were already committed beyond their capacity, stocking America's existing aircraft fleet. Northrop availability gave it a window of opportunity. On the 5th of November, Northrop and Pavleka met at Wright Field with Air Materiel Command officers and presented them with Northrop's preliminary design. The Douglas XA-26A night fighter proposal was the only competition. Northrop's design was selected. Following the USAAC acceptance, Northrop began a comprehensive design work on what would become the first dedicated night fighter. The result was the largest Pursuit-class aircraft flown by the US during the war. The aircraft was huge, as Northrop had anticipated. While far larger and heavier multi-engine bombers existed, its 45.5 feet or 14-meter length, 66-foot or 20-meter wingspan, and projected 22,600 pounds or 10,251 kilo full load weight were unheard for a fighter, making the P-61 hard for many to accept as a feasible fighter aircraft. Some alternate design features were investigated before finalization. Late in November 1940, Jack Northrop returned to the crew of 3 and twin-tail rudder assembly. To meet the USAAC's request for more firepower, designers abandoned the ventral turret and mounted 4 20mm Hispano M2 cannons in the wings. As the design evolved, the cannons were repositioned in the belly of the aircraft. The P-61 therefore became one of the few US-designed fighter aircraft to have a quartet of 20mm cannon, along with the NA-91 version of the Mustang, and the US Navy's operated F-4U-1C Corsair, as factory standard in World War II. Following a few small changes, Northrop's NS-8A fulfilled the USAAC's requirements, and the Air Corps issued Northrop a letter of authority for purchase on December 17th. A contract for 2 prototypes and 2 scale models to be used for wind tunnel testing was awarded on the 10th of January 1941. Northrop's Specification 8A became, by designation of the War Department, the XP-61. Northrop's engineers built a full-scale wooden mock-up of the XP-61. So, on March 10th, another contract was approved by the Undersecretary of War. This ensured the production of 13 YP-61s, and the groundwork was laid for the production of the airframes that would become the famous P-61 Black Widows. It was also a rather large aircraft for a fighter, at 50 feet long and a wingspan of 66 feet. The P-61 was a twin-boom design with a crew consisting of a pilot, gunner, and the new member, a radar operator. He would operate the compact airborne interceptors specifically designed to fit inside an aircraft, leaving out the middleman who had previously relied on instructions from radar-operated out-of-ground stations. The production model of the SCR-720A mounted a scanning radio transmitter in the aircraft nose. In airborne intercept mode, it had a range of nearly 5 miles, or 8 kilometers. The unit also functioned as an airborne beacon or homing device, navigational aid, or in concert with interrogator responder units. The XP-61's radar operator located targets on his scope and steered the unit to track them, vectoring and steering the pilot to the radar target via oral instruction and correction. Once within range, the pilot used a smaller scope integrated into the main instrument panel to track and close on the target. This rotating 30-inch scanner receiver dish antenna would sweep the sky with a knife-like beam. When used, it reduced the ground echoes that plagued long-wave radars at low altitude. This shorter wavelength enhanced accuracy, betting interceptors within just 100 yards of intruders in total darkness. His radical shift was the main reason that the Black Widow could fly at night, as the device allowed pilots to navigate and locate airborne enemies in real time. Red-colored cockpit lighting was another innovation that further aided the vision and night fighting. The Black Widow's lethal bite could rival any that the enemy had to offer. It was armed with 4 20mm Hispano M2 forward-firing cannons mounted in the lower fuselage and 4 50 caliber M2 Browning machine guns lined up horizontally with the 2 middle guns slightly offset upwards in a remotely aimed dorsally mounted turret. A similar arrangement to that used in the B-29 Superfortress, using 4-gun upper-forward remote turrets. The XP-61's spine-mounted dorsal remote turret, driven by the General Electric gyroscopic fire control computer, could be aimed and fired by the gunner or radar operator, who both had aiming control and gyroscopic collimator sighting posts attached to their swiveling seats, or could be locked forward to be fired by the pilot in addition to the 20mm cannon. The radar operator could rotate the turret to engage targets behind the aircraft. Capable of a full 360 rotation and 90-degree elevation, the turret could be used to engage any target in the hemisphere, above and to the sides of the XP-61. The unique system was to often have difficulty achieving an accurate aim. The P-61 was powered by 2 Pratt & Whitney R2800 double Wasp radial engines, each packing 2,000 horsepower. The 2 engines were each mounted approximately 1/6 out on the wingspan. It was capable of a maximum speed of 366 miles an hour, which was relatively fast considering its immense size. The P-61 also had an internal fuel capacity of 646 gallons. Its estimated fighting weight was over 29,000 pounds. Main landing gear bays were located at the bottom of each nacelle, directly behind the engine. Each engine cowling and nacelle drew back into tail booms that terminated upward in large vertical stabilizers, and their component rudders, each of a similar shape to a rounded right triangle. The horizontal stabilizer extended between the inner surfaces of the 2 vertical stabilizers, and was approximately 3/4 the chord of the wing root, including the elevator. The elevator spanned approximately 1/3 of the horizontal stabilizer's width, and an overhead plan view angled inwards in the horizontal from both corners of the leading edge towards the triangle edge approximately 15 degrees, forming the elevator into a wide, short trapezoid. Leading edge updraft carburetor intakes were present on the wing shoulder and the root of the outer wing, with a few inches of separation from the engine nacelle itself. Thin horizontal rectangles, with the ends rounded out to nearly a half circle, with multiple vertical vanes inside of it to direct the airstream properly. The main fuselage was centered on the aircraft's centerline. It was, from the tip of the nose to the end of the plexiglass tail cone, approximately 5/6 the length of one wing. The nose housed an evolved form of the Signal Corps' radar SCR-268, the Western Electric Company's SCR-720A. Immediately behind the radar was the multi-framed greenhouse canopy, featuring 2 distinct levels, one for the pilot and a second for the gunner above him and behind him, the latter elevated by approximately 6 inches or 150 millimeters. The forward canopy in the XP-61 featured contiguous, smooth-curved, blown plexiglass canopy sections facing forward, in front of the pilot and the gunner. Beneath the forward crew compartment was the nose gear wheel well, through which the pilot and gunner entered and exited the aircraft. The radar's operator station was at the aft end of the gondola. The radar operator controlled the radar set and viewed its display scopes from the isolated rear compartment, which he entered by the way of a small hatch with a built-in ladder on the underside of the aircraft. The overall design was exceptionally clean and fluid, as the aircraft possessed very few sharp corners or edges. Another stealthy innovation was the new glossy black paint in the metal armor instead of the usual olive green and gray paint. Like flight tests in Florida in October 1943 pitted both schemes against each other, the black color was not detached in 80% of flights throughout the gauntlet of anti-aircraft searchlights. Starting in February 1944, all Black Widows were painted deep black, allowing the P-61 to truly fit its name. It took Northrop engineers over a year and a half to fix developmental delays and revisions. All the while, the Army Air Forces were desperate to start training night pilots. They have no problem getting the crews of volunteers to the training. Redesigns during the production phase cost Northrop 2 critical wartime years. Although its late rollout and obsolescence will ultimately be its demise. The Black Widow delay is turned into a platform for innovation. The P-61's official public debut was quite dramatic. In January 1944, AA-61 performed a nighttime flyover of the Los Angeles Coliseum, filled with 75,000 attendees as part of a new Army-Navy show. According to some accounts, the crowd couldn't see the plane and could only hear its engines passing over. The first squadron to fly the Black Widow in Europe was the 422nd Night Fighter Squadron on May 23, 1944. Almost a month later, the 425th Squadron received their Black Widows. However, both of them received the aircraft too late to participate in the D-Day invasion on June 6th. The first P-61 engagement in European theater occurred on the 15th of July, when a P-61 piloted by Lieutenant Hermann Ernst was directed to intercept a V-1 flying bomb. Diving from above and behind to match the V-1's 350-mile-an-hour speed, the P-61's plastic rear cone imploded under pressure and the attack was aborted. The tail cones failed on several P-61A models before this problem was corrected. On the 16th of July, Lieutenant Ernst was again directed to attack a V-1, and, this time, was successful, giving the 422nd NFS and the European theater its first P-61 kill. The absence of turrets and gunners in most European theater P-61s presented several unique challenges. The 422nd NFS kept its radar operator in the rear compartment, meaning the pilot had no visual contact with the operator. As a result, several pilots continued flying their critically damaged P-61s under the mistaken belief that the radar operator was injured and unconscious, when he had already bailed out. The 425th NFS moved the radar operator to the gunner's position behind the pilot. This provided an extra set of eyes up front and moved the aircraft's center of gravity about 15 inches or 380 millimeters forward, changing the flight characteristics from slightly nose up to slightly nose down, which improved the P-61's overall performance. By December 1944, P-61s of the 422nd and 425th NFS were helping to repel the German offensive known as the Battle of the Bulge, with two flying cover of the town of Bastogne. Pilots of the 422nd and 425th NFS switched their tactics from night flighting to daylight ground attack, strafing German supply lines and railroads. The P-61's 420mm cannon proved effective in destroying German locomotives and trucks. During this battle, the P-61 obsolescence became apparent. Lieutenant van Nieuwswande was piloting his Daisy May Black Widow when an encounter with the twin-engine Messerschmitt 410 led to a pursuit across the top of the woods. This wonder attempted to attack and follow its enemy by chasing it at full throttle, but by the time the Black Widow caught up, the ME-410 pulled away at 400 miles an hour, making the P-61 seem painfully slow in comparison. The 422nd and 425th Squadrons also found themselves critically short of spare parts by the end of 1944. Being a smaller company, Northrop couldn't keep up with the demand and supply issue was never corrected. The squadron had made do with whatever equipment they had on hand. Most operational 61s ended up being sent to the Pacific. After Guadalcanal was secured in late 1942, the American stronghold urgently needed nighttime protection from Japanese nighttime raids launched out of bases in the surrounding areas. The Black Widows weren't ready yet, so the Americans temporarily adapted B-25s, P-40s, P-38s, and P-70s as night fighters. Finally, in May 1944, the Black Widows were ready to fly in the Pacific. The first to receive a P-61 was the 6th Night Fighter Squadron. They were the only night fighting squadron until the 418th and 419th Squadrons also began working with Black Widows. On July 1st, 1944, the 421st Squadron was also activated, and, operating from bases at Nadzab, New Guinea, and Wake Island, actual fighting by the P-61 was sparse. The 418th Squadron, based on the island of Morotai in the Hull, Maharas, and the Duchious Indies operate at the top, scoring Black Widow. Highlighting the P-61 light action and combat, the 418th conducted a mere 18 successful attacks. Its most triumphant mission came when the 3 Kawasaki Ki-61s were destroyed in a single night. Despite its innovative design, the P-61 was only able to play a minor role during the last 6 months of World War II. The Axis powers were already too weak to put up much of a fight on the ground, let alone in the air. The Lady in the Dark 61, piloted by Captain Lee Kendall, is perhaps the best-known Black Widow in the world. The fighter was photographed hundreds of times in the Pacific Theater. It was also the aircraft that presumably scored all the final 2 aerial kills of World War II. The first kill happened on the night of the war, and the second one almost an entire day after all battles had officially ended. Captain Kendall took down Japanese Imperial Army aircraft in kamikaze missions by aggressively pursuing them and causing them to crash on their own. The P-61 proved capable against all Japanese aircraft it encountered, but saw too few of them to make any significant difference in the Pacific War effort. Simply put, the 61 arrived too late to World War II. Although it was useful in battles against the Japanese Air Force, it was already obsolete in Europe by the time it got there. Northrop engineers tried to fix as many issues forced by the P-61 as possible. He redesigned the airborne intercept radar and improved the remote control turret. Turbochargers were also added to the aircraft, but it still lagged in speed. Despite his late arrival, Black Widow still saw combat in every theater of World War II. The fighter destroyed a total of 127 enemy aircraft and 18 German V-1 buzz bombs. The useful life of the Black Widow was extended for a few years into the immediate post-war period due to the USAAF's problems in developing a useful jet-powered night/all-weather fighter. Shortly after the war, a Black Widow was used in early American ejection seat experiments. The P-61 was heavily involved in the Thunderstorm project from 1946 to 1949, a landmark effort to gather data on thunderstorm activity. The project was a joint effort by 4 U.S. government agencies, the U.S. Weather Bureau and the NACA, assisted by the U.S. Army Air Forces and Navy. Scientists from several universities also helped the launch, design, and conduct of the project, which aimed to learn more about thunderstorms and how to better protect civil and military airplanes from them. The P-61's radar and particular flight characteristics enabled it to find and penetrate the most turbulent regions of a storm, and returned crew and instruments intact for detailed study. Surviving aircraft were offered to civilian governmental agencies, or declared surplus and offered for sale on the commercial market. 5 were eventually issued civil registrations. The P-61 was, in fact, a remarkable response to the mission set for it, but that mission had already changed before it got into combat. Northrop, a small manufacturer that rose to meet the challenge, did an amazing job of building a sophisticated, new technology airplane that had no precedent. They didn't adapt an earlier design to become a night fighter or base the P-61 on anything that already existed. They started with a clean sheet of paper and invented the first all-weather day-night interceptor. In that sense, it was the beginning of today's anytime, anywhere 24-hour U.S. Air Force. It was the start of something else big, too. Oddball specialty airframer Northrop aircraft, once small enough that it could be given the night fighter assignment without disturbing the work of such long-gone industry giants as Republic and North American, is today the Northrop Grumman Corporation, the 5th largest defense contractor in the world.
Originating from a design philosophy dating back to 1930, but conceived during the Second World War, the XCG-16 glider emerged as one of the most unconventional and innovative glider concepts ever tested. Initially designed for transporting heavy equipment and supplies, including vehicles and military personnel, the XCG-16 later became involved in experiments to deliver fuel to long-range bombers during flight. As a crucial element of the war effort, it showcased the capability to transport substantial loads without the need for an engine. Despite its troubled test history and eventual exclusion from production, the XCG-16's design retained its distinctive features. The roots of the XCG-16 can be traced back to May 1930, when American aero engineer Vincent Bernelli explored various lifting theories and flying wing concepts. The United States Army Air Force subsequently issued a specification calling for a novel design incorporating Bernelli's patented lifting fuselage concept. To assess the most suitable design for military use, a competition among different aircraft manufacturers was organized at Wright Field. Designers Hawley Bolus and Albert Kriz utilized Bernelli's concept as a foundation to create their own glider for the competition. Bolus, previously focused on designing leisure aircraft and recreational vehicles for the civilian market, ventured into military aircraft design for this competition. His most notable design had been the Bolus Road Chief, the trailer and caravan upon which Airstream had based their famous design. He'd also worked as one of the consultants on the Spirit of St. Louis, the aircraft piloted by Charles Lindbergh, who completed the first non-stop transatlantic flight between New York and Paris. Despite lacking experience in combat and military design, Bolus moved forward with his concept, collaborating closely with Kriz and the team at his company, Bolus Sailplanes. The German military's successful use of gliders during the 1940 invasion of Belgium, particularly in landing troops in challenging areas behind Belgian lines, drew attention. Gliders played a crucial role in capturing strategic sites, exemplified by the rapid overrun of Fort Aben-Amal in May 1940, where glider-borne Nazi soldiers surprised Belgian troops. While the United States initially maintained neutrality in the early stages of the war, experiences like the Battle of Fort Aben-Amal prompted the United States Army Air Corps to take gliders seriously into consideration. In response to the USAC's request for a glider capable of transporting troops, heavy equipment, and supplies towed behind engine-driven bombers and transport planes, Bolus and Kriz diverged from the traditional single fuselage design that characterized most American gliders. Instead, they embraced a flying wing concept, closely studying Bonelli's philosophy and incorporating their own ideas on top of it. A half-size prototype model was created in late 1942 by Bolus Sailplanes, with Bolus and his team considering the initial test results to be good. The first full-size glider prototype, named the MC-1 glider, was produced by General Airborne Transport. Following the closely followed design of the half-size model, initial factory tests once again indicated the potential of the new design. The full MC-1 design was envisioned to be larger than other gliders of its time. It was characterized by a high wing configuration with a wooden frame and fabric covering, all while retaining Bonelli's philosophy. With a wingspan of 110 feet and a length of 67 feet, the MC-1 boasted substantial dimensions. Bolus aimed for a cargo capacity of up to 15,000 pounds, facilitating the transport of both cargo and troops through two large cargo doors located at the glider's front for easy access and rapid deployment during battle situations. The intended operational method involved towing the XCG-16 into the air by a C-47 or C-54 Air Force transport plane, which would then release the glider to continue its flight independently. The glider featured a twin boom design for the tail. Designed with spoilers, the XCG-16 could deploy them to reduce lift and increase drag, enabling rapid descent and short landings on various terrains. Additionally, the glider was equipped with retractable landing gear, deployable for landings on rough ground. The maiden flight test of the MC-1 began on the 19th of July 1943 at March Field, California. The first test run proved to be a success and was commended by military and business observers. A second test flight was scheduled at March Field on the 11th of September 1943, but this run ended in disaster. Among the crew and passengers aboard the glider were notable aviator and businessman Richard Chichester DuPont and military glider specialist Colonel Ernest Gable, who was set to pilot the MC-1 for its demonstration. During the demonstration, the glider was towed by a Lockheed C-60. Shortly after takeoff, an unintended encounter with the C-60's prop wash caused the glider to violently sway from side to side. Compounding the issue, the weight ballast inside the glider had not been properly secured and began to shift, exacerbating the rapid tilting of the XCG-16. Recognizing that a crash landing was imminent, 3 of the passengers, including DuPont, attempted to parachute from the glider as it continued its descent. While 2 passengers successfully landed safely, DuPont tragically lost his life when his parachute didn't open in time. Colonel Gable remained on the glider and also lost his life when it ultimately crashed into the ground. Despite the tragic setback at March Field, Bolus continued with the design and the US military awarded a contract to the General Airborne Transport Company in November 1943 after negotiations. The contract approved the construction of 3 MC-1 units. 2 flyable and 1 for static tests were awarded by the USAF. The completed full-sized MC-1 gliders were also given the military designation XCG-16, and the name stuck. Only 1 completed XCG-16 unit was manufactured and submitted for USAC testing. Test pilots and engineers acknowledged the XCG-16's strong aerial performance, highlighting its excellent stability and maneuverability. However, military observers concluded that the glider fell short of expectations in terms of cargo and loading capabilities, deeming it unsuitable for combat situations. Consequently, no additional units were produced. There was initial consideration of repurposing the glider for new Air Force experiments. In 1944, the US military explored the concept of extending the range of existing transport and bomber aircraft by utilizing trailing gliders to carry fuel. The XCG-16 airframe was handed over to the Cornelius Aircraft Company, known for building gliders, to modify and test the forward-swept wing design, capitalizing on the XCG-16's robust capabilities. The Cornelius Company made several alterations to the glider, renaming it the XFG-1 and prepared it for a test flight. However, the first XFG-1 model crashed during a demonstration in October 1944. Although a second model was produced by Cornelius following the bolus format, by that time the US military had lost interest in the project, leading to the discontinuation of further development.
From 1933 until the end of the Second World War, German aviation led the world in aerodynamic design and technical innovation. Long before the outbreak of hostilities, German industry produced an armada of technically superior warplanes. When war broke out, the Luftwaffe quickly overwhelmed some of Europe's most vaunted air forces. Classic designs like the Bf-109 fighter and Ju-88 proved to be superior fighting machines, while others like the Blumenvoss BV-141 became one of aviation's true oddities. The Blumenvoss company was one of the first to respond with their BV-141. Designed around the concept of maximum all-round view, the BV-141 was in many ways a problem looking for a solution. The unorthodox design featured an asymmetric layout with the radial engine installed at the front end of a port-side tail boom and an extensively glazed crew nacelle mounted to starboard. Unusual and radical in design, the BV-141 performed surprisingly well, but in the end it was considered too unconventional and it was cancelled in 1943.
Yes, in my meanderings throughout Germany, just after the capitulation, I was looking for unusual or advanced technology aircraft. And the 141 intrigued me a little, but I had heard that they were at an airfield called Grossenhain, which was quite near Meissen. There was a big reconnaissance unit which had many reconnaissance types of aircraft, and I thought maybe the 141 will appear there. So I flew there, and there was no sign of one, but I asked if I could speak to some of the POWs who were in the cage there, and one of the chaps told me that a 141 had indeed been there, but the last he remembered of it was not too long ago. It had had an engine problem while flying nearby and had landed on an emergency strip east of Grossenhain. So I flew over in that direction looking for this strip. But it wasn't really a strip, I found. It was a small airfield. And it was, by this time I'd moved into the Russian occupation zone. And I decided to land there because I had already found that at that stage after the war, the Russians were still very amenable to the Brits because we had come in at the early stages of the war to help them. Anyway, when I landed, there weren't a lot of aircraft there, and there was a Russian commissar and with an interpreter, and I asked if there was a 141 there. He didn't really know things like the aircraft numbers, but he said there were 1 or 2 aircraft left, but his people had examined the airfield, taken away what they wanted, and the rest was left for destruction. So I said, could I have a look around, see what there was? He said, well, yes, why not? Because it's all going to be destroyed anyway. And in one hangar, there was indeed a 141. It had regularly had its engines run up by Feldwebel, who was available. And I said to him, was the aircraft flyable? And he declared, oh, yes, it was. I rather suspected his motive, so I wasn't too sure of what he was saying or believing what he was saying, because I think he had hoped I would fly him out of there and out of the Russian zone. But the Russians were obviously not going to play with that. Anyway, I thought I'll take his word for it and have a go at this. And the commissar didn't object. He said, as long as I stayed within sight of the airfield, and I'd only have enough fuel to do that, he didn't mind, because it was due for destruction anyway. And so he let me fly that, and I had about 30 to 40 minutes in it to try out this theory that it flew very nicely in a straight line when on an angle of bank of 90 degrees. And after about 2 or 3 goes at this at various speeds and heights, I had trouble with the engine. So I had to return to base. And so I formed an impression that it probably did what it said it could do. But its real reason for failing, in my opinion, was it certainly wasn't an aircraft in the same category of handling as the Focke-Wulf 189, which I had already flown and was its competitor.
Another odd-looking aircraft was the Focke-Wulf 189. The completely glazed central nacelle, twin engines and tail booms were considered too radical for conservative Luftwaffe officials. Performance, however, won the day. Known as the Flying Eye, the FW-189 proved supremely versatile, universally popular, and one of the most reliable aircraft ever to see Luftwaffe service. During combat operations, the FW-189 surpassed all expectations. Despite flying low over the battlefield and taking large amounts of damage, it had the ability to absorb punishment and fight another day.
So I think that killed it more than the theory that it gave the gunner a wonderful field of fire by having no starboard half of the tailplane and being asymmetrically offset to give a clear field of fire to the gunner. So that was my experience of it. Not very impressive, but interesting.
So many of the ingenious designs for aircraft put to paper throughout history never came into production or often died at the prototype stage. Some of these aircraft became conceptual legends, and others were instead renowned for their absurdity. The Bartini-Biriev VVA-14 is a bit of both, not least because of its purpose and the colourful inventor behind its design. Perhaps the best means of understanding the genius behind the plane is to understand the genius behind its creator, Roberto Bartini. Bartini was born in the infamous city of Fiume, in what was then Italy and is currently modern-day Croatia. He would live through the early part of the 20th century through political uproar and the reorganization of states and borders that took place as a result of the First World War. He showed a passion for aviation early on in life, and more specifically for innovative aircraft designs and concepts, a passion which would lead the Italian engineer to the Soviet Union. After studying engineering at the ancient and world-renowned University of Bologna, often recognized as the Oxford of Italy, he joined the revolutionary aircraft manufacturer Caproni, where he worked alongside his mentor, the creative genius Giovanni Caproni. During his time at Caproni, Bartini was instrumental in making key innovations and design improvements in a number of the company's aircraft. However, Bartini's life would change completely when he was offered the opportunity to participate in aeronautical research in the Soviet Union. Fascinated by the career opportunities and prospects, Bartini accepted the offer. However, his decision to leave Italy was layered. Post-World War I Italy was politically and economically unstable. Furthermore, Bartini was an avid socialist and felt that the Soviet philosophy of strongly supporting scientific innovation would create potential for significant advancements in new aircraft technologies. From the moment Bartini arrived in the Soviet Union, he found himself directly involved in a variety of important projects. He began research at the Central Aero Hydrodynamic Institute, known by the acronym TSAGI, in Moscow, where he contributed greatly to a number of aircraft designs and concepts. However, Bartini had a knack for innovation and showed a notable prowess in engineering that made him stand out compared to his colleagues. He was quickly recognized for his notable mind when it came to aeronautics. His creativity and inventiveness earned him a reputation as a man with an unconventional but effective approach to aircraft design. Before he even began work on the Bartini Biriev, he designed the Bartini Stal 7, an elegantly designed twin-engine flying-wing transport aircraft, which would act as an inspiration for the Year 2 and the Year 4. Although the plane never went into production, it displayed the Italian engineer's uncanny ability to bring unconventional aircraft designs to life in a manner that similar engineers of his day were unable to do at the time. During the 1930s, Bartini began researching what would be the genesis of his masterpiece, the Bartini Biriev VVA-14 submarine hunter. Bartini began researching seaplanes and amphibious aircraft for their dual civilian and military applications. His early designs made use of retractable landing gear and hulls which were optimal for waterborne operations. Bartini's seaplane concepts were seen as impressive for their time and earned him significant status amongst his peers. World War II would see Bartini's expertise come to center stage. His contributions were essential to the Soviet Union's war effort. His experience was put to use on a myriad of projects, which included strategic bombers and reconnaissance aircraft. While Bartini's career was ultimately marked with success during his time in the Soviet Union, he did experience difficulties in his personal life. He underwent uncomfortable periods of political scrutiny and surveillance during the iron-fisted years of Stalin's regime. Yet Bartini managed to navigate the complex maze of Soviet politics and ultimately preserve his position as a respected aeronautical engineer. The apex of Bartini's career will be his work on the Bartini Biriev VVA-14 submarine hunter, a conceptual design which he began work on in the late 20th century. Even by today's standards, it was a marvel of engineering and design, capable of landing on any surface and taking off from any position. Known in Russia as the Vertikalno Vzleta Yashaya Amphibia or vertical takeoff amphibious aircraft, the VVA-14 was a highly experimental plane developed by the Soviet Union. It was intended to harness the abilities of a high-velocity aircraft combined with those of a seaplane. It also took advantage of the ground effect, compressing air in order to create a cushion between it and the water, meaning it could effectively function as a ship if needed. The question remains, why did Moscow want Bartini's airplane design to have so many different capabilities? The answer? Anti-submarine warfare, or ASW for short, and who better to design such a plane than one of the foremost amphibian aircraft experts in the world? The project began in the 1960s. Its scope was to create a submarine hunting aircraft that could operate in vastly different environments, from remote areas to coastal regions and large bodies of water. The VVA-14 had a uniquely long range and the ability to fly at unusually high speeds while carrying a large payload of radar equipment and other reconnaissance technology. The VVA-14's central fuselage extended forwards and backwards, housing the cockpit and engines. The wings were mounted above the fuselage with two pontoons directly beneath them. The pontoons not only allowed for water takeoffs and landings, but also provided extra fuel storage and contained regular landing gear as well. Perhaps the most impressive aspect of the plane, especially at the time it was conceived, was its VTOL functions. The VVA-14 used a special propulsion system to enable this. The plane came with two separate engine types, lift engines and cruising engines. The lift engines were located in the fuselage and could rotate to create vertical thrust for sustained hovering and VTOL capabilities. The engines responsible for lift were typically turbo engines, like the Kalinin RD-3635, and they were potentially capable of producing a titanic 8,800 pounds of thrust. Horizontal flying relied on turbofan cruise engines in the fuselage, like the Lyalka AL-7F. These engines produced a whopping 20,000 pounds of thrust. Different prototypes of the VVA-14 varied in the quantity of these engines used. Once finally in flight, the VVA-14's wings would rotate into position and the lift engines would reposition into a horizontal configuration. The cruise engines would then take over the forward flight function. The VVA-14's VTOL capability would have made it ideal for operating in extremely unconventional environments where other planes couldn't actively take off and land, such as bodies of water. This functionality also made the aircraft highly fuel efficient. The plane had channels which directed air beneath it, creating a cushion or gap which effectively allowed the VVA-14 to act as a hovercraft and therefore ship on the water. Overall, the plane's test runs were not unpromising. It reached an impressive top speed of 550 km an hour for a plane of its size, and water taxiing proved relatively successful. Perhaps most notably of all was the plane's odd design. Aside from being a truly hulking vehicle, it looked extremely modern for its time. The VVA-14 looked more like a comic book spaceship than a conventional airplane, with its back-mounted boosters and W-shaped body. This unique aesthetic was typical for Bartini's aircraft, which often sat at the cutting edge of aeronautical design. The conceptual outlines for the Biriev BE-1 and the Biriev BE-2500 reflected the very same ingenuity and prowess. Bartini's concept was undoubtedly a theoretically perfect answer to an increasingly hard-fought war against submarine technology. However, his prototype airplanes did not come through without their significant challenges and technical problems. One major issue was the plane's VTOL flight. The batteries needed to power the lift engines were never delivered, therefore the Kalinin RD-3635 was never used to help the plane take off or land vertically. The aircraft's highly complex design led to stability and control problems. Its unconventional configuration, using a variety of different engines, resulted in an inability to reach optimal stability. Furthermore, the plane's complexity meant maintenance was a nightmare. The engine's swiveling mechanisms added yet another layer of difficulty to properly maintaining and repairing the plane, all while raising the number of potential points of failure. And like any project, the VVA-14 suffered from budgeting issues. The cost of developing and testing the aircraft required multiple expensive prototypes, and Bartini's innovations, while genius, were extremely costly. Ultimately, the VVA-14 sucked up more resources than could be appropriately allocated to it. This is in part what led to the project's cancellation, especially given that the increased funding needed could not be justified against other Cold War expenses. In the end, priorities in the military were changing, and the Soviet Union and Navy decided to focus on an entirely different type of aircraft. The project was slowly deprioritized and cancelled. Bartini's submarine hunting beast never saw operational duty and ultimately fell to the wayside, ending up in a museum of aeronautics in Moscow, a shell and memory of the tireless work that went into creating an entirely new species of aircraft. However, despite the plane's ultimate failure as a project, Martini's innovations and concepts were some of the most riveting and impressive for their time. He remains one of the earliest proponents of VTOL flight, and his designs are still unconventional and highly avant-garde by today's standards. Roberto Martini knew how to push boundaries in a way that made him truly unique. His multidisciplinary approach incorporated disciplines from hydrodynamics to biomimicry. He turned to every source of inspiration he could in designing his planes. Perhaps that's why they were so futuristic. Maybe Martini's VVA-14 went the way of all truly genius designs. Perhaps it was too far ahead of its time. Shining a light on his ideas means his legacy can go on, and that the genius that went into making his aircraft was not lost in vain.
As Britain and the Allies struggled for survival in a fierce battle with the Nazis, American industrial might was mobilized to supply them with the weapons and machines to beat back the German onslaught. Millionaire Howard Hughes was anxious to participate in the war effort to do his part to defeat Hitler. His intentions were not completely altruistic. A military contract would also have been extremely profitable. Hughes built the prototype D-2, a speedy wooden fighter/bomber, entirely with his own money and in secret. He hoped to amaze the U.S. Army Air Force with it, but the plane was flatly rejected. Fortunately for Hughes, he had friends in high places. When President Roosevelt declared war on December 8, 1941, he had not only to consider the fate of the free world and the lives of millions of American soldiers, he also had to weigh the risks to his own sons. Elliott Roosevelt was a member of the U.S. Army Air Force. He had received his captain's commission on his 30th birthday in 1940. At the time, Roosevelt was battling for a third term in office, and there were cries of nepotism. But General Henry Hap Arnold, chief of the Air Corps, silenced those rumors. Elliott Roosevelt's poor eyesight left him classified as 4F, or unfit to fly, but he still managed to carve out a respectable career, participating in 89 combat missions. Reconnaissance was his specialty, and he was considered the leading expert in recon in the European theater, and a pioneer in aerial night photography. While commanding the 3rd Reconnaissance Group in Operation Torch, the invasion of North Africa, Roosevelt had a chance to fly on board a speedy de Havilland Mosquito. He was so impressed with de Havilland's wooden wonder, he became a passionate advocate of British aircraft and believed American-made B-17s and P-38s were sitting ducks against the German defenses. His enthusiasm may have blinded him when a sly Howard Hughes presented him with a prototype for his own wooden aircraft, the D-2. The D-2 was a twin-boom fighter just like the Vultee Swoosh Goose, designed by Hughes' former employee Richard Palmer. Palmer left Hughes for Vultee because he was tired of the company's lack of focus. The D-2 also had a remarkable resemblance to the P-38 Lightning. They were so similar, Hughes did not believe it was a coincidence, and he testified to the Senate that Lockheed had stolen his design. Though the D-2 had been rejected by the U.S. Army Air Force, when Colonel Elliott Roosevelt came to town looking for a new reconnaissance plane, Hughes dazzled him Hollywood-style to salvage a contract. The P-38 Lightning had been the workhorse reconnaissance plane for the U.S. Army Air Force, but by 1943, they were looking for an upgrade. Colonel Roosevelt, an expert in recon, was asked to explore what aircraft were in the works that might take over for the P-38. Hughes spared no expense when Roosevelt came to see his plant in Culver City, California. A line of limousines greeted the president's son and his staff at the airport, and they were taken on the trip of their lives. Women and starlets were thrown at them. They were treated to Hollywood's most extravagant parties in the hottest nightclubs. A married Roosevelt was introduced to his next wife, Faye Emerson, an up-and-coming actress with whom he would have a scandalous affair. In the midst of all this partying, there was time to see the D-2. Its Duramold body, a type of plywood bonded with plastic and molded under heat and pressure, would certainly have impressed Roosevelt, who was enamored with a Mosquito. By the time Colonel Roosevelt left California, he was sold on the D-2. He became an enthusiastic salesman for Hughes when he briefed General Arnold and his father on the project. Arnold was in a difficult position, as Material Command had already rejected the aircraft. They did not believe Hughes had the facilities or track record to deliver on an order. In the end, Arnold had no choice but to listen to the president's son. He ordered the XF-11, an all-metal and larger reconnaissance version of the D-2. The decision caused an uproar in the Army Air Force, not only because the D-2 had been rejected, but also because they already had a similar plane in development, the Lockheed Chain Lightning. The XP-58 was a long-range heavy fighter which could outperform the D-2, and it came from a known and reliable aircraft and manufacturer, the P-38 Lightning, built by Lockheed. Uproar or not, Elliott had his father's ear. Hughes won a $43 million contract to build 100 XF-11s, a contract that would be worth $500 million today. Unfortunately for the Army Air Force, their worst fears about Hughes came to be. Work progressed slowly on the XF-11. Each of its Pratt & Whitney 28-cylinder radial engines drove a pair of contra-rotating four-bladed controllable pitch propellers. It was hoped this style of prop would increase performance and stability, but the whole system was too complex and ultimately scrapped. As years passed, the XF-11 project, forced on the U.S. Army Air Force, became increasingly unpopular. The original D-2 prototype was mysteriously destroyed in a fire in November of 1944. At the time, Hughes and the U.S. Army Air Force were fighting over who should pay for the original development costs. With the prototype a pile of ash, the two sides agreed to split the costs. It was an accident which was highly convenient for the millionaire. Like the XF-11, controversy followed Colonel Roosevelt as the war progressed. Project Aphrodite was a joint mission between the U.S. Navy and U.S. Army Air Force to destroy heavily fortified German submarine pens and V-2 sites with bomber drones. The pilot and co-pilot would take aircraft heavily loaded with explosives to altitude before parachuting to safety. A mothership remotely controlled the bombers the rest of the way via radio. In later years, Elliott Roosevelt claimed to be in the Mosquito chase plane that recorded the tragic death of Lieutenant Joe Kennedy Jr., brother of future President John F. Kennedy. His plane inexplicably detonated before it reached its target. Elliott asserted that he actually flew through the deadly fireball that ensued, but there is no record of the president's son participating in the mission. There was also some controversy when Roosevelt was finally awarded his wings. General Arnold, who had been forced to accept Hughes' XF-11, also had his arm twisted to intervene in Colonel Roosevelt's final promotion. In January of 1945, Arnold ordered General Carl Spaatz to appoint Elliott, whose poor vision had left him classified as 4F, or unfit to fly, as a rated pilot. The president then submitted his son's name to the Senate for promotion to brigadier general. On April 12, 1945, America mourned the death of President Roosevelt. He had accomplished much during his tenure, guiding them out of the Depression and through the war. As tragic as his passing was, it did untie the hands of General Arnold. He was finally able to put millionaire Howard Hughes in his place. The XF-11 order was canceled a month after the president's death on May 11, 1945, though Hughes was allowed to continue to work on the prototypes. By the time the war ended, Hughes still had little to show for all the money spent on the XF-11. It would be another year before a prototype would fly, and the first flight ended in a crash that nearly killed him. the XF-11 was not Hughes's only multi-million-dollar scandal. His behemoth transport, the H-4 Spruce Goose, was more of a lame duck and was yet to fly. With millions of dollars poured into both projects, questions swirled in the Senate about what Hughes was doing with the money. In 1947, the Brewster Committee looked into the spending irregularities surrounding these projects.
I put the sweat of my life into this thing. I have my reputation rolled up in it. And I have stated several times that if it's a failure, I'll probably leave this country and never come back, and I mean it.
Elliott Roosevelt and Johnny Myers were also called as witnesses. Myers, a publicist who worked for Hughes, gave a detailed expense report of all the perks Roosevelt had received during his time in California.
Well, now, can you tell me why you were charging up to aircraft production $132 for nylon hose for Miss Emerson?
Because she'd been very charming. Just like the presidents up higher. The girls were very pleasant.
What has that got to do with aircraft production?
They just went along. Every company in the business did it. We're no different.
Well, but is it, you say because she was very charming, that's the reason that you charged up $132.
That's right.
For the which would go into the production of airplanes.
That's right.
And now, will you tell us why you gave her $20 and charged it up to the company to go home if she was very charming?
Well, you taught me.
Myers had even paid for Roosevelt's wedding to Faye Emerson. In his defense, Roosevelt claimed that he first heard about the XF-11 after the Culver City visit in a briefing from Arnold.
And there are efforts to find out whether there was any connection that I might have had with the chief executive, which might have had an effect on any war contracts. And I'm here to give you the complete facts. It is undoubtedly true that he bought some tickets to from New York to Washington. But I still want you to put the question to him, was he completely positive that one of those tickets was for Elliott Roosevelt?
Well, I'll put it right to him now. Mr. Mars, what do you say? Look at that sheet. You told us about them being lost and buying the fares back. Now, what do you say about it?
Just what it says here. It says Colonel Elliott Roosevelt Party.
Yeah.
So I didn't testify that he was one of them. He could have been one of the other fellows. Did I say that under the word Elliott Roosevelt Party? What?
During a break in hearings, Hughes decided to give the Senate all the evidence they needed that the Spruce Goose was fit to fly. While taxi testing the aircraft, he took the H-4 on its first and only flight. In daredevil fashion, Hughes proved to the cameras and reporters that the millions of American tax dollars had not been squandered or misappropriated. The millionaire used his Hollywood dazzle to save his own skin.
He decided he wanted to design aircraft when he was 12 years old after reading Tom Swift and his airplane. He designed his first plane before he'd ever seen one in person. When he first applied for a job at Lockheed, the company turned him down flat. He got his master's degree in aeronautical engineering and returned, and was rewarded for his persistence with an $83 a month job as a tool designer. By the time his career at Lockheed ended 47 years later, he had built the most important aircraft research and design facility in the world. There, in Lockheed's legendary Skunk Works, he and the team he led revolutionized aviation. For 30 years, it was impossible to see a significant display of American aircraft without seeing something Kelly Johnson had designed. Whether it was a fighter, bomber, transport, passenger liner, or even a spy plane, the odds were that he had designed at least part of it. Without question, he is the greatest aircraft designer in history. He is Clarence Kelly Johnson. Clarence Kelly Johnson was born in the town of Ishpeming in Michigan's Upper Peninsula on February 27, 1910. The son of Swedish immigrants, he got his Irish nickname from schoolmates after he stood up to the school bully.
He had been dealing with some of the kids at the school calling him Clara, since his first name was Clarence. And he finally had his fill of it and decided to take reprisals on one of the bullies. And after he was finished, the kids in the schoolyard decided that he could no longer be a Clara, and instead they were going to find some more appropriate name. And since Irishmen were known at that time for their pugilistic skill, they decided to dub him Kelly.
He designed his first airplane, which he called the Merlin Battle Plane, as a 12-year-old, and it won him a prize at school. He knew then that was what he wanted to do with his life. He paid $5 for his first flight, a 3-minute trip in a biplane that ended badly when the plane's engine conked out at 700 feet. When he got older, he worked in construction and in the Buick factory and saved his money. He took his savings to a flight school and asked to be taught to fly. The flight instructor, a cash-strapped barnstormer, refused Johnson's money and told the young man to spend it on college. Johnson enrolled at the University of Michigan just before the stock market crash in 1929 and supported himself washing dishes in fraternity houses. As an assistant in the aeronautical engineering department, he worked with the school's wind tunnel. The school allowed him to rent the tunnel out when it wasn't in use. Johnson charged $35 an hour and helped design a new, streamlined Studebaker model. He graduated in 1932 and tried to enlist in the Army Air Corps, but was refused. He returned to Michigan for his master's degree and, among other things, used the Michigan Wind Tunnel to help design aerodynamic racing cars for the Indianapolis 500. In 1933, he went to work for Lockheed in California as an $83 a month tool designer. Lockheed at the time was a deeply troubled company. It had just emerged from bankruptcy and had bet its future on the Electra, a 2-engine transport. When Johnson arrived in Burbank, his boss asked him what he thought of the plane. Johnson looked and said it would be unstable and that he did not trust Lockheed's wind tunnel tests. Chief Engineer Hall Hibbard sent Johnson back to Michigan with a model of the Electra and a mandate to do his own study in his own wind tunnel. "See if you can do better," Hibbard told him. He did. After 72 tunnel tests, Johnson came up with a newly designed flap system and traded the Electra's single stabilizer for a twin tail. Those changes stabilized the Electra and helped make it one of the most successful airplanes of its time. Johnson returned to Lockheed a full engineer. Assigned as the Model 10 Electra's flight test engineer, he at last started flying on a regular basis. He befriended Amelia Earhart and advised her on several of her missions. She flew an Electra, and Johnson advised her on techniques of fuel mixing to help her get the best performance out of her plane. He continued to work on updates to the Electra through Electra Model 14, and was soon attracting attention outside of Lockheed. In 1937, he won the Sperry Award for Outstanding Achievements in Aeronautics by a young man. That same year, Congress passed the Neutrality Act. That law was designed to keep the United States out of World War II. At the same time, those in the military had become convinced that American involvement in the war was inevitable. They threw as many of their precious dollars as they could into the design of new equipment. Lockheed won the competition to build a new fighter with a plane designed by Johnson, the XP-38. With 2 engines and a double fuselage, it was an unconventional aircraft that had its share of problems. In particular, its high speed and tight maneuvering sometimes created forces so great that they shattered the plane in midair. Once again, Johnson went back to his wind tunnel, and after making a few changes to the plane's design, it passed Army Air Corps muster and was ordered into limited production. Johnson, the designer, was 27 years old. In the late 1930s, Lockheed came back from bankruptcy largely on the strength of its commercial aircraft. The Electra in particular had built a profitable customer base. But if Lockheed was going to grow, it was going to have to build a successful military aircraft business. The P-38 was a start, though when the Army Air Force first awarded the contract, no one knew how many thousands of planes would eventually be built. In 1938, with Europe on the brink of war, the British sent a purchasing commission to the United States in search of military aircraft, particularly a long-distance coastal patrol bomber that could be used to hunt submarines. The commission, scheduled to visit several aircraft manufacturers, did not originally intend to visit Lockheed. Their schedule changed at the last minute, and Lockheed was invited to make a presentation, with only 5 days to prepare. During the 5 days of preparation for the Brits, Johnson showed what he was destined to become famous for: the ability to make something entirely new out of existing components, and to manage a project to completion with a ruthless eye to the deadline.
He himself lived by the credo, be quick, be quiet, be on time. He was somebody who believed very much in getting good people and giving them the ability to do what they do best. He also believed in minimizing the number of people working on any one project.
In only 5 days, Johnson and his crew not only redesigned the Electra to fit the needs of the Royal Air Force, they also built from scratch a full-scale wooden model of the plane, a civilian transport converted into a medium bomber. The Brits were amazed. They were so impressed by Johnson and his crew, they invited Lockheed executives to England to confer with the Air Ministry. Johnson went along. At the meetings, the British changed the design specifications, necessitating a complete redesign of the aircraft. Johnson locked himself in a London hotel room and in only 72 hours completed the engineering drawings. The British were, once again, amazed, and Lockheed got the contract. But not before the British expressed their hesitancy about working with an engineer as young and inexperienced as the 28-year-old Johnson. Lockheed reassured the Air Minister, who ordered 200 of what became known as the Hudson Bomber. It was the largest single order of aircraft ever received by an American manufacturer, and upon the party's return to the United States, Lockheed promoted Johnson to chief engineer. In 1939, the Congress significantly increased the defense budget, and P-38 started rolling off the line in record numbers. During this period, Johnson truly mastered the art of manufacturing, streamlining production processes, and developing an entirely new job, the program manager. Now a staple of manufacturing, the program manager is a person far down the chain of command who has working control of a project. If that all seems a bit heavy on the business administration in a discussion of aircraft, consider this. Johnson believed that outstanding aircraft designed and manufactured quickly were inevitably the product of a single visionary. That visionary was usually, of course, Johnson.
He was not someone who believed in development via committee. He was also somebody who hated lengthy reports and normally limited any report that was sent to him to 20 pages. He believed in brevity, he believed in clarity, and he believed in giving people the tools necessary to get the job done.
In 1943, Lockheed put Johnson in charge of advanced products research, setting him up on a plot of land on the outskirts of Burbank, California. Johnson called his new kingdom the Skunk Works, after the still in a cartoon strip, Little Abner, that was responsible for the making of a mysterious and powerful brew called Skunk Works.
In the Little Abner cartoon, there was a potent mystery elixir known as Kickapoo Joy Juice. And Kickapoo Joy Juice was made at the Skunk Works, or Skonk Works, as it was called in the comic strip, through a variety of things that were thrown into a giant mixture, among them skunks, old shoes, and things like that. And the nickname was applied to the Lockheed operation because, indeed, it was a mystery elixir. Nobody was quite sure what was going on in there, but they knew that a lot of things were being thrown into it and that Kelly Johnson was pulling a lot of people from various locations in order to create something interesting.
The job of the Skunk Works was to quickly, cheaply, and secretly develop advanced aircraft that could help win the war. Its first assignment was the P-80 Shooting Star, the first American jet. Intelligence had determined the Germans were far along in their development of jets, and the not-so-secret fear of the Army Air Force was that the Nazis would deploy their jets in large numbers before the war in Europe had ended. The effect on the Allied bombing campaign would have been horrendous. The Allies' propeller-driven fighters would have been almost useless against a jet-powered fighter.
Kelly Johnson, in his efforts to oversee those operations, would pull people from other projects and would go about trying to get a minimum number of the very best people and put them on the project, give them minimal supervision, but let them trust them to be able to do the jobs that they're chosen to do.
After setting up the Skunk Works and recruiting his team, Johnson went to work on the P-80. Lockheed's contract with the Army Air Force gave him an incredibly short schedule, 180 days. Johnson went on a binge of designing and set his team to work on various critical paths and had the prototype ready for testing 37 days ahead of schedule. In 5 months, Lockheed had designed and built the first American jet. They hauled it from Burbank to Muroc Air Base in the California desert for testing. Fearful that there might be spies in the surrounding hills, they disguised the jet during transport with a plywood propeller. Johnson said years later that when he rolled out a new plane for testing, there was only one thing he thought about. What have I forgotten? In the case of the P-80, despite the short design and construction cycle, he hadn't forgotten much. It was a beautiful aircraft, faster and more agile than anything in the American arsenal. The war ended before it saw combat, but it evolved into the T-33, one of the best and longest-lived jet trainers in history. When the war ended, however, there were those who questioned whether the Skunk Works had a role to fill. After World War I, the business of aviation had shrunk almost to non-existent. After World War II, many people expected that it would again. But there were two basic differences between the ends of the wars. First, the United States was engaged in the world after World War II in a way it wasn't after World War I. No one could reasonably expect the world's only nuclear power to go back into hibernation. And second, before the war ended, it became clear that the post-war world would require a strong and ready military. Because on the day the Japanese surrendered, the world separated into two groups of allies, those in the communist East under the control of Joseph Stalin, and those in the democratic West. World War II was over, but the Cold War was just beginning. Kelly Johnson and the Skunk Works were just about to become the most important aircraft developers in the world. Over the course of his career, Kelly Johnson designed more than 40 aircraft. His most prolific period by far was in the 1950s. That was a decade of tremendous technological advance, achieved in an atmosphere of never-ending crisis, and there was no better place for aeronautical engineers to work than the Skunk Works. Johnson designed and built the Constellation, the most elegant aircraft of its time, and a plane that served effectively in both civilian and military roles. He experimented unsuccessfully with vertical takeoff and landing aircraft, with the idea that they could operate from relatively small ships. He designed the F-104 Starfighter, at 1,300 miles an hour, the fastest aircraft ever flown at the time. It was a sometimes fussy plane to fly, and at more than Mach 2, there wasn't a lot of room for error. It was adapted around the world to a number of difficult tasks, including carrying nuclear weapons. Johnson didn't approve of all the modifications others were making to his plane, but could do little about them. As the Cold War heated up, it became clear that the United States needed a way to peer deep into Russian territory. East of the Ural Mountains, where the Russians did their atomic research and where they developed their aircraft and missiles, the United States didn't even have an accurate topographical map, let alone a way of getting information on military capabilities. The Air Force put out a quiet request for a fast, high-altitude plane that could overfly Russia and bring back pictures of the communist secret bases. Johnson at first toyed with modifying the F-104, but it lacked the range and would be too difficult to fly on long missions. In 1954, he sent the Air Force a proposal to build a plane that could fly at a range of 4,000 miles above 70,000 feet. It would be slower than the Air Force had hoped, but at that altitude would be high above Russian air defenses. The Air Force didn't believe Johnson could do it. They doubted any jet engine would work at that altitude, and instead ordered a competition between manufacturers for the best spy-plane design. President Eisenhower approved a $35 million contract with the competition winner. Johnson and his Skunk Works team went into overdrive. In mid-November 1954, he met with the government advisory board on what was then called the CL-282 project. 10 days later, he formed the team to design the craft. On December 2nd, the first 12 engineers went to work designing the aircraft systems, and the first design drawings were completed and released to the shop for manufacture the next day. A week later, the drawings were complete, and by the end of the year, he'd won the contract and frozen the design. Wind tunnel testing completed in March, the first plane finished in July, and the first flight took place on August 4th, 1955. In less than a year, from pipe dream to first flight, Kelly Johnson and the Skunk Works had designed and built a completely new kind of airplane. The U-2 had something of a patched-together quality, to be sure. The first ones cut weight by leaving out the ejection seat, and the balancing wheels on the wings dropped off at takeoff to lose a few more pounds. The engineers were still making modifications on the craft in the summer of 1956, when a young pilot named Francis Gary Powers saw his first U-2 parked on a taxiway at a secret base in Nevada. It had not been built to last, he said years later. Powers was among the pilots who flew spy missions over the Russian heartland in the U-2, and for years it was safely out of range of the Soviets. The planes routinely returned with photographs showing Russian fighters 4 miles below them, coming up for a fight but unable to fly high enough to get a shot off. Eventually, however, the Russians improved their air defenses, and by the time Powers was shot down in 1960, Johnson was already at work on his next-generation spy plane. Johnson, with the U-2s flying with seeming impunity, had gone back to the government to propose a plane that could fly 10,000 feet higher and 4 times as fast as the subsonic U-2. Building a plane that would cruise at Mach 3.2, Johnson said years later, was the hardest thing the Skunk Works ever did. Everything about the plane, Johnson said, had to be invented. In 1960, the Air Force gave the go-ahead for Johnson to develop the A-12, a plane that didn't succeed as an interceptor, but paved the way for its slightly larger sister, the SR-71 Blackbird. Built out of titanium, which is light and could tolerate the 500-degree temperatures that built up as the plane sliced through the atmosphere at more than 3 times the speed of sound, the Blackbirds were like something out of a science fiction movie. The rollout was Johnson's proudest day. It was, he said, the smoothest test flight he'd ever been through. Johnson, who had never been much of a talker, insisted that he was not bothered by the fact that he couldn't talk about his perfect airplane. If I can talk about it, he'd like to say, it's obsolete. But years later, when word of the SR-71 had leaked out and the Air Force had stopped denying its existence, he took joy in its racing from New York to London, a distance of almost 3,500 miles in less than 2 hours. And before the Blackbirds were retired in March 1990, an SR-71 flew across the United States coast to coast in 68 minutes. Kelly Johnson retired from Lockheed in 1975. Even then, he was a presence at the Skunk Works. His 14 rules of effective program management are gospel there and are taught in some of the leading business schools in the world. Johnson even consulted with Lockheed during the development of the F-117 stealth fighter. As an old man, he said that there would come a time when aircraft were no longer relevant. People wouldn't travel for business, he said, because they could sit at their desks and talk to people in Europe by video phone. And on the battlefield, manned aircraft were no longer cost-effective in an age of missiles. Though it hasn't happened yet, don't bet against it.
I think his greatest contribution was in the vision that he had for the Skunk Works, for Lockheed, for American aviation, and in his ability to translate that vision into something that other people embraced and believed in and wanted to work toward. To a great extent, his greatest contribution was his ability to get other people to commit to his dream.
Kelly Johnson died just before Christmas in 1990.
Johnson would be partially responsible for the financial attitude implied in the prototyping of the Model 22, which later would become world-renowned as the P-38 Lightning. The cutting-edge Lightning was a twin-engine, twin-boom, twin-tail interceptor pursuit aircraft that eventually became a pivotal combat aircraft in World War II. The design and engineering that went into the P-38 were the handiwork of aeronautical engineers Hibbard and Johnson, and the first example, the one-off XP-38, made its first flight on January 27, 1939. Secretly, a number of advanced features were being incorporated into the new fighter, including a significant structural revolution in which the aluminum skin of the aircraft was joggled, fitted, and flush riveted. A design innovation not called in for the Army's specification, but one that would yield less aerodynamic drag and give greater strength and lower mass. As a result, the XP-38 was the first 400-mile-per-hour fighter in the world. It was flown by a USAAC AMC engineering test pilot, First Lieutenant Benjamin Scoville Kelsey, who was a fighter project officer in the engineering division of the AMC and one of the P-38's biggest supporters. In fact, he helped convince the USAAC to procure the type.
He may be the only person in history who fell in love with flight because President Calvin Coolidge took a vacation. A baby-faced Swede who flew a trainer in a loop around the center span of the Golden Gate Bridge. He was a stunningly talented pilot. It was said of him that he thought more quickly in 3 dimensions than most people did in 2. His string of combat victories over New Guinea turned him into a national hero. He shot down an incredible 40 enemy aircraft before being removed from combat once and for all. A national treasure who could no longer be risked on the battlefield. When the endless cycle of parades and war bond rallies wore him down, he asked for and received assignment as a test pilot in the secret program that produced America's first combat jet. He is Richard Ira Bong, and he is a legend of air power. Richard Ira Bong was born September 24, 1920 in Superior, Wisconsin. Superior is a small town at the western tip of Lake Superior and about as far north as you can be in Wisconsin without being in Minnesota. His father, Carl, had come to the United States from Sweden at the age of 7. He worked his way halfway across the continent before settling as a farmer in Poplar, Wisconsin, 20 miles to the southeast of Superior. Carl Bong married Dora Bryce and settled in to start a family. Richard was the first of their 9 children, a quiet, thoughtful boy who grew up hunting and fishing in the dense forests around his family's farm. Known from an early age as Dick, he was first taken with aviation at the age of 8, when President Calvin Coolidge decided to spend a summer vacation in Superior.
And every day the mail would be delivered by a courier, air courier, and Richard saw the plane going over to every day, and I think it just fascinated him, and I think that was the start of his love affair with aviation, and it just built from there.
When the presidential party left town, so did the air couriers, but aviation had made its impression on young Dick. He contented himself with building model airplanes and dreaming of the day when he would learn how to fly. He played basketball, baseball, and hockey. He was a fisherman and hunter, played clarinet in the school band, and was active in the local 4-H club. He was, like almost everyone else in Poplar, a Lutheran, and he sang tenor in the choir every Sunday morning at Bethany Lutheran Church. Poplar was a town so small that his high school only lasted 3 years. To complete his senior year and make himself eligible for college and the civilian pilot training program, he commuted 44 miles round trip every day to Superior. In 1938, he graduated 18th in a class of more than 400. He attended Superior State Teachers College and enlisted in the civilian pilot training program. That government-sponsored flight training system was designed to boost the number of experienced pilots in the United States. The government justified the program based on the growing need for airmail and commercial pilots. In reality, the government's main concerns were the wars that were brewing in Europe and Asia. There was going to come a time, military planners believed, when the United States would need a lot of pilots quickly. Bong earned his pilot's license in a Piper J3, and almost from the first showed a gift for aviation.
He had a knack for it, and he learned that through the pilot training programs he had been in college and afterwards, that he was just a natural pilot, and that was the word that everybody used to describe him in all of his pilot training programs. He was just a natural pilot. He loved it, and it became evident in the performance he turned in as a pilot.
In 1941, Bong enlisted in the Army Air Aviation Cadet Program. In May, he shipped out to far-off and exotic California. He did his primary flight training in a Stearman biplane outside Tulare. He caught on quickly and moved on to flying Vultee BT-13s, the famous Vultee vibrator at Garner Field in Taft.
He was, as I said, a natural pilot. He had natural skills, natural abilities, and in those days, you didn't get a whole lot of instructions.
Most of the pilots at Gardner simply flew, running up their hours and getting a feel for maneuvering in 3 dimensions. Bong quickly distinguished himself and was ordered to report for gunnery training. At Luke Field near Phoenix, Arizona, he moved from the BT-13 to the AT-6, a single-engine fighter trainer that was smoother and more capable than the Vultees he'd been flying, but sluggish compared to real combat fighters. His gunnery trainer was Captain Barry Goldwater, the future senator and presidential candidate. Goldwater, a tough, precise teacher, said later that Bong was a talented pilot. In those years, hunting with his Winchester rifle in Wisconsin had honed his shooting skills. But Bong really proved himself one afternoon in an informal, impromptu hassle high over Luke Field. Bong, flying an AT-6, squared off against a Czech pilot in a P-38. The dogfight should have been a mismatch. The P-38, after all, was much faster and more agile than the AT-6, and the Czech pilot had hundreds of hours more flight time than Bong. But no matter how the P-38 pilot maneuvered, he couldn't keep Bong off his tail. The two would square off, and in a few seconds, Bong would be closing in on the P-38 from behind. The Czech pilot, upon landing, pronounced Bong the best natural pilot he had ever seen. Bong was at Luke when the Japanese bombed Pearl Harbor in December 1941. Like the other pilots, he wanted into the war as soon as he could get there. A month later, he received his wings and his officer's commission. But rather than sending him into combat, the Army kept him at Luke as a gunnery instructor. Dick Bong's war seemed to end before it had started. For almost 6 months after the American entry into World War II, Second Lieutenant Dick Bong was stuck stateside. As a gunnery instructor at Luke Field in Arizona, he trained other young fighter pilots and then watched as they departed for points unknown overseas. In May 1942, however, the Army Air Force assigned Bong to Hamilton Field in San Francisco. There, pilots were learning how to fly the new Lockheed P-38 Lightning fighter. The P-38s were big, fast, and had proven themselves unsuitable for combat in Europe. The cooling systems for the plane's twin engines froze up at low temperatures common at altitudes over Europe. The pilots training in P-38s at Hamilton all understood where they were headed: the Pacific. After arriving at Hamilton, Bong quickly came to the attention of Major General George C. Kenney, commanding general of the 4th Air Force. Bong was both a gifted pilot and an incorrigible hot dog. On training flights, he liked to dip down low and buzz San Francisco's downtown. Showing off for the civilians seemed to be his greatest joy in life, and it got so bad that General Kenny put out an official order that such antics would not be tolerated.
Well, as most pilots are prone to do, he disregarded that instruction and, in fact, went out and did a couple loops around the middle span of the Golden Gate Bridge, went down Market Street waving at the secretaries as he was buzzing through town, and had gotten so low that evidently he blew down somebody's laundry. And that woman actually filed a complaint with General Kenny.
Kenny knew, of course, that Bong's juvenile clowning was not altogether a bad sign. There's a long tradition of cocky fighter pilots indulging their whims. Indeed, Kenny knew that confidence and spirit were traits necessary for fighter pilots to survive in combat. Still, he was a general, and generals have to at least attempt to keep a lid on their pilots. He disciplined Bong regularly, making him wash, dry, and fold the laundry he had blown off the clothesline, for example. But he also took note of the young pilot's enormous skills in the air.
He actually spotted the spark, I think, when he called him on the carpet in his office. He was, I don't know what he was expecting when this pilot walked in the door, but here comes this, average size 5'8", blonde-haired, baby-faced Swede who appeared to be scared to death that he was going to lose his wings.
Bong's passion for flight so impressed Kenny that when General Douglas MacArthur chose Kenny to set up the 5th Air Force Base in the Southwest Pacific, Kenny made sure that Bong was one of the first pilots sent to his new base in Australia. He arrived in September, springtime in the Southern Hemisphere. For more than a month, Bong sat around in Brisbane awaiting delivery of his plane. In November, Kenny assigned him to temporary duty with the 35th Fighter Group based in Port Moresby, New Guinea. New Guinea at the time was a hornet's nest of Japanese aircraft. MacArthur's campaign to reclaim the Philippines had just begun. American forces were beginning the bloody harbor-to-harbor conquest of New Guinea. The Japanese were throwing everything they could at the arriving American forces. The Army Air Force used a kind of sink-or-swim training method, throwing green pilots into the periphery of battles to ready them for full-fledged air combat. Flying under the careful tutelage of an experienced combat pilot, Captain Tom Lynch, Bong flew long patrols and skirted air battles for nearly a month, learning from Lynch the best tactics for fighting in a P-38. Then, on December 27, 1942, Bong got his first real taste of battle. He was in a flight of 12 P-38s led by Lynch. The flight intercepted 40 Japanese aircraft over Buma on New Guinea's northwest coast. Badly outnumbered, the P-38s charged headlong into the formation. Bong showed no sign of the fear he surely felt. He scored a Zero fighter and a Val bomber. Altogether, the P-38s knocked down a dozen Japanese aircraft. Bong, who had never been in real combat before, earned a Silver Star for his actions. From that point on, in dependable, almost unspectacular fashion, Bong began to compile what turned out to be the finest combat record in the history of American aviation. It took him only until January to become an ace, scoring his 5th kill over Leh Harbor. In February, Bong left Lynch's shadow and returned to the 9th Fighter Squadron. On March 3rd, on the opening day of the Battle of the Bismarck Sea, Bong flew escort for a flight of B-25 and B-17 bombers attacking a Japanese convoy. Bong knocked down a Zero. The bombers sank 4 Japanese destroyers and 8 transports. 1 and 2 kills at a time, Bong upped his total. Kenny promoted him to first lieutenant and gave him a 2-week leave in Australia. By then, a double ace, Bong enjoyed his R&R but longed to get back into action. The Japanese were throwing thousands of aircraft at the advancing Allies, creating aces almost as fast as the Allies could get pilots into the air. But Bong, perhaps uniquely among American pilots, seemed more interested in the experience and challenge of flight than he was in his kill count.
He was an introvert on the ground, shy even. In the air, became a different person, became the ultimate fighter pilot.
On July 26, Bong had his best day ever. Escorting American bombers attacking Leh, he knocked down 4 Japanese fighters. General Kenny, who had been so impressed by Bong's skills in training, could barely believe how proficient a warrior the unassuming Swede had become. He put Bong in for a promotion to captain and filed an after-action report that resulted in Bong receiving the Distinguished Service Cross. Bong was, in fact, emerging as a leader in the almost unspoken competition among pilots to become the ace of aces. He became one to watch. The press started wiring accounts of his combat accomplishments back stateside, and his name started to be mentioned in speculation about whether an American pilot would break Eddie Rickenbacker's seemingly unbreakable record from World War I, 26 combat victories. In November 1943, Bong shot down his 20th and 21st enemy aircraft, a pair of Zeros over the airfield at Rabaul. General Kenny, knowing that his ace pilot was as valuable as a morale-building hero as he was in the air, gave Bong a 60-day leave to return home for a visit. Bong met with General Hap Arnold, posed for a few pictures, and then returned to Poplar, Wisconsin to enjoy, as ordered by Kenny, a little home cooking. The leading ace of the war was welcomed home as a hero, and while being crowned as honorary homecoming king at his old college, he met Marjorie Vattendahl, the 19-year-old homecoming queen. For the next 2 months, if he wasn't busy appearing at war bond rallies or launching ships for the war effort, he and Marjorie were together. By the time he left Poplar on the long journey back to the Southwest Pacific, he and Marjorie were in love. Captain Richard Bong returned to the Southwest Pacific as the leader in the race to become the ace of aces, in hot pursuit of Eddie Rickenbacker's combat kill record. Bong slapped his girlfriend's picture on the nose of his new P-38, which he christened Marge. 5 victories behind the record set by Eddie Rickenbacker in World War I, he went into battle with the whole world watching and an advantage over his competition. He was assigned not to the 9th Fighter Squadron, but to 5th Air Force Headquarters. In the competition to become ace of aces, the flyer with the most kills, Bong had become the favorite. The press had gathered to watch his achievement. While other pilots' assignments were limited to specific geographical areas where there might or might not be enemy activity, General Kenny allowed Bong to roam where he liked, in search of action and Japanese planes to shoot down. But they increased slowly. The number of Japanese aircraft had decreased, and the enemy was shifting to a more defensive posture. That limited the number of mass attacks that had created so many American aces. The Southwest Pacific was about as unnatural a habitat for the Wisconsin farm boy as it's possible to imagine. Hot, humid, bug-infested, and moldy, it was a place that seemed to reek of death. Bong went out almost daily, enduring long, boring patrols. Often he found no enemy aircraft at all. When he did, the combat lasted only minutes, and then a long return flight, often over open water, to inhospitable accommodations. That was his reward. On February 15th, the day after Valentine's Day, Bong recorded his first kill in the plane he'd named for the girl back home, Marge. It was his only official kill for the month, though he did destroy a transport as it sat on the runway. The transport, it turned out, was loaded with high-ranking Japanese officers, and while it didn't count on his kill total, it struck a significant blow to the Japanese war effort. On March 8th, the tedium of the war turned to tragedy. Bong had reunited with his former commander from the 35th Bomber Group, Lieutenant Colonel Tom Lynch. The two were flying over Atape Harbor, New Guinea. Bong watched helplessly as his old friend and mentor spun down to his death. For the next month, Bong was ineffective in combat, He flew, but he didn't score any kills until April 3rd, when he knocked down his 25th enemy aircraft. The press gathered in anticipation. The folks back home waited for word of Bong's heroism. On April 12th, Bong shot down 3 enemy planes in a single day, shattering Rickenbacker's record. The news splashed around the world. Rickenbacker sent a telegram congratulating Bong and promising to send a case of scotch as a reward. General Kenny, doubly pleased that the record had been broken by an officer in his command, sent a case of champagne. Back in the States, Middle America was scandalized that people would send alcoholic beverages to a pilot in a combat zone. To quell the uproar, General Hap Arnold made a big show of shipping Bong 2 cases of Coca-Cola. Arnold slipped the press copies of his personal note to Bong, stating that America's newest hero would certainly prefer America's favorite soft drink. Bong, still the cheerful, baby-faced kid from the north woods of Wisconsin, was having a ball. What he didn't realize is that by becoming the ace of aces, he had become a national treasure, too precious to risk in combat.
After he broke Rickenbacker's record at 26 victories, they did everything they could to the point of sometimes setting him down or sending him back on, publicity campaigns and things like that back in the States to keep him out of harm's way.
He returned to the United States, went on a war bond tour, and most importantly, proposed to Marge Vattendahl. He didn't return to combat for 5 months, reporting to General Kenny in September 1944 as a gunnery instructor. He could fly, but he was only allowed to fire in self-defense. He defended himself a lot. He shot down 5 enemy planes in October and 3 more in November. Kenny suggested to General Douglas MacArthur that Bong ought to get the Congressional Medal of Honor. MacArthur agreed and forwarded Kenny's request up the chain of command. In December, Bong went to Tacloban to receive the Congressional Medal from General MacArthur himself. In December, Bong shot down 4 more planes, bringing his total to 40. General Kenny, who had bent every rule to keep Bong flying, once and for all, pulled him out of combat. He shipped his favorite pilot back home, armed with a personal letter to General Hap Arnold and 6 bottles of Coca-Cola for the flight. Bong arrived back in the United States on New Year's Eve, 1944. He went to Washington, met with Hap Arnold, and participated in what seemed like an endless stream of public appearances, including a press conference with Eddie Rickenbacker. He broke away in February and returned to Wisconsin. There, in the Concordia Lutheran Church, he and Marge married. After his honeymoon, Bong received the plum assignment of flight testing the P-80 Shooting Star, the first American jet. He made 11 flights in the P-80, immersing himself in the theory and engineering of jet engines. On August 6th, he pointed the nose of his jet down the runway for his 12th flight. The plane rolled down the runway perfectly, but as it rose into the air, the engine flamed out.
Here's a guy that had, 200 missions, combat missions in the Pacific, shot down 40 enemy airplanes, was shot at on a daily basis, won the Congressional Medal of Honor, comes back to what's supposed to be a relatively safe stateside job, and dies in an accident on takeoff in an experimental airplane, the P-80, in California.
Dick Bong, the ace of aces, died the day the Enola Gay dropped the atom bomb on Hiroshima. His death, which would have made headlines almost any other day of the war, made barely a ripple in the public consciousness on that particular day. The bomb had dropped. The war Bong had fought in so heroically was about to end. As the whole world prepared to celebrate the end of World War II, Poplar, Wisconsin mourned. In tiny Poplar Cemetery, Dick Bong came home for good.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.